The moon's volcanoes are not dormant, and they can erupt any minute. For years, we lived knowing nothing about it, but now it's officially proven thanks to China's Chang'e 5 mission's shocking discovery. The lunar soil samples it brought back to Earth contained something absolutely unexpected, hinting that volcanic eruptions may have occurred on the moon as recently as 123 million years ago. Geologically, that's practically yesterday. But the big question is, are we safe down here on Earth? We've long known that the moon was once volcanically active due to the dark regions, lunar maria, on its surface. These maria, the dark plains that give the moon its characteristic markings, are ancient lava flows that date back to around 3 to 3.8 billion years ago. Until recently, scientists thought that those ancient flows marked the end of the moon's volcanic activity. But the Chang'e 5 mission brought back lunar soil that included several microscopic glass beads, and 3 of them in particular revealed an extraordinary story. They formed around 123 million years ago from volcanic eruptions. An uncertainty range is a mere 15 million years. The discovery of those tiny beads is super important because of their composition and rarity. Measuring between 20 to 400 microns, which is smaller than a grain of sand, these beads are volcanic in origin. And this fact sets them apart from most other lunar glass beads, which typically form due to meteor impacts. Impact events on the moon create glass by melting surface rock with incredible heat and pressure. The result is tiny glass beads scattered all over the landscape. Yet, the volcanic beads identified in Chang'e 5's sample were formed by magma erupting from beneath the moon's crust and cooling it into glass as it reached the surface. By using uranium-lead dating, which measures the decay of uranium into lead within the beads, scientists managed to pinpoint their age with striking accuracy. The results suggest that the last known volcanic activity on the moon happened within the past 200 million years, making it a recent event in the moon's long history. This discovery also aligns with prior observations of unusual surface features known as irregular mare patches. Those are smooth mounds surrounded by rocky terrain. They were first spotted by NASA's Lunar Reconnaissance Orbiter in 2014. These patches appear much younger than other lunar features, potentially formed by volcanic eruptions less than 100 million years ago. Before Chang'e 5's glass beads, these irregular mare patches were among the best evidence of recent volcanic activity on the moon. Yet, without confirmation, their origins remain uncertain. And now, the glass beads confirm volcanic action. The findings raise new questions about the moon's inner workings. In particular, how could it retain enough heat to sustain volcanic eruptions? We thought that the moon had cooled significantly after its formation 4.5 billion years ago, which made it volcanically inactive. And without tectonic activity or an atmosphere, the moon should have shed its internal heat long ago. Yet the beads suggest the possibility of some localized heat sources within the moon's mantle. Scientists think that heat-producing elements such as potassium and thorium might be creating small, warm pockets which generate enough heat to melt rock and trigger isolated volcanic eruptions. But wait, beyond rewriting the moon's history, this discovery adds an intriguing twist to ongoing studies of transient lunar phenomena. These sightings, often reported as ghostly glows or hazes, but if the moon has small pockets of volcanic or outgassing activity, TLP might have a real basis. Gases emitted from beneath the surface could explain such mysterious glows and possibly be a hint of residual volcanic action on the moon. Now, if volcanic activity still lingers on the moon, this might have exciting implications for future lunar missions. In the coming decades, astronauts might be able to use volcanic heat for generating power, melting ice into water, or even warming bases built into the frigid lunar surface. But recent geological discoveries aren't limited to Earth's natural satellite. We learn more about volcanic moons beyond our solar system too. The detection of a possibly volcanic exomoon orbiting exoplanet WASP-49b around 635 light-years away means that volcanic activity may be a common feature among moons. Up until now, Jupiter's moon, Io, held the title of the most volcanic body we know about. But researchers at NASA's Jet Propulsion Laboratory may have found a new candidate. This potential exomoon came to light when scientists observed a cloud of sodium gas around the exoplanet. But the thing is, sodium clouds are unusual in planetary atmospheres and can suggest volcanic activity. The sodium cloud near WASP-49b had a bizarre, unexpected behavior. It was moving erratically, shifting size, and occupying a space too large to be explained by the exoplanet's own atmosphere. Scientists thought the cloud could actually be generated by a volcanically active exomoon in orbit around WASP-49b. Volcanic moons like Io are known to release gases such as sulfur dioxide, sodium, and potassium, which form massive clouds around their parent planets. Io, for instance, regularly produces vast amounts of gas that form a cloud encircling Jupiter, up to 1,000 times the size of the gas giant itself. If something similar occurs near WASP-49b, the gas cloud could be a clue to volcanic activity on an exomoon orbiting the planet. Observations from the European Southern Observatory's Very Large Telescope in Chile seems to confirm this theory. The sodium cloud around WASP-49b is positioned high above the exoplanet's atmosphere and behaves in ways that don't match the exoplanet's 2.8 Earth day orbit. This could suggest that it originates from a separate body, likely a volcanically active moon. Additionally, WASP-49b and its host star consist primarily of hydrogen and helium, which makes the sodium cloud even more unusual. The observed rate of sodium release, over 220,000 pounds per second, can be a sign of an immensely powerful volcanic source. If scientists verify the existence of this exomoon, it would be the first discovery of a volcanic exomoon. Back in our solar system, Io remains the main space object helping us understand volcanic moons. Recently, NASA's Juno spacecraft provided some of the closest images of Io since the Galileo mission over 25 years ago. Io's intense volcanic activity is caused by tidal heating, the result of the gravitational pull of Jupiter and nearby moons, like Europa. This tug-of-war generates immense friction within Io, producing heat that fuels continuous volcanic eruptions. One of Juno's most exciting recent findings was a new volcano that appeared just south of Io's equator. Juno's images show a large, complex volcanic region, approximately 111 by 111 miles in size. The craziest thing? It wasn't there when Galileo imaged the same spot in 1997. This new volcano formed near the volcanic structure is a great change that highlights the dynamic nature of Io's surface. Io's equatorial region is home to most of its volcanoes because of the concentrated tidal heating it experiences. The most powerful eruptions emit sulfurous gases and produce bright lava flows. They cover the moon in colorful, sulfur-rich deposits. JunoCam's image, taken from about 1,570 miles away, shows Io dramatically lit by sunlight reflected off Jupiter, and you can see a stunning view of its constantly changing volcanic surface. Despite these detailed observations, there are still many mysteries about Io's volcanism. Scientists are particularly curious about how tidal heating affects Io's interior, and whether it has a subsurface magma ocean. Plus, researchers try to understand what triggers different types of eruptions. For example, plumes versus lava flows, and how volcanic gases shape Io's surface and thin atmosphere. The study of volcanic moons from Io to the possible exomoon near WASP 49b sheds light on how tidal forces create volcanic activity in different moons. In icy moons like Europa, tidal heating sustains liquid oceans beneath the surface, creating potential habitats for life. But for Io without an ocean, the same forces instead generate powerful volcanic activity. Plus, if volcanic exomoons do exist, like the one possibly orbiting WASP 49b, we might soon discover more volcanic bodies across the galaxy.
The largest volcanic region on Earth is not in Africa or Japan, but under the ice of Antarctica. Scientists found 138 volcanoes in its western part, and if they decide to go wild, you'll surely notice it. They could melt huge amounts of ice that will move into the ocean, raise its level, and make our planet uninhabitable for humans. But before you pack your things to fly away to another planet, hear me out. Only 2 of the Antarctic volcanoes are officially classified as active now. And it would take a whole series of eruptions, decade after decade, to seriously impact the whole world. Mount Erebus, one of the 2 Antarctic volcanoes currently in action, proudly bears the title of the world's southernmost active one. It has been continuously erupting since at least 1972. It emits plumes of gas and steam and sometimes even spews out rocks, and scientists call it Strombolian eruptions. One of the coolest features is a lava lake in one of its summit craters, with molten material on the surface. Such lakes are rather rare because they need certain conditions to make sure the surface never freezes over. The second active volcano is Deception Island, a horseshoe-shaped landmass. It is the caldera of an active volcano that last erupted over 50 years ago. Scientists who monitor it say it shouldn't go wild anytime soon. Antarctica also has plenty of fumaroles. Those are volcanic vents that release gases and vapors into the air. In the right conditions, they can spew out enough stuff to build fumarolic ice towers up to 10 feet tall. Scientists keep an eye on the Antarctic volcanoes with seismometers that detect when the Earth starts trembling from volcanic activity. Sometimes they also use more complicated tech, but it's all really challenging because of how far away this polar region is and how tricky it is to get there. That's why no one can predict when one of the continent's volcanoes that are now sleeping might erupt. We can guess what this waking up would look like if we analyze the events from nearly 20,000 years ago. So, shall we? One of Antarctica's sleeping volcanoes, Mount Takahe, had a series of eruptions and spewed out a good amount of halogens rich in ozone back then. Some scientists say these events warmed up the southern hemisphere. Glaciers started to melt and help finish the last ice age, with substances rich in halogens from one or more volcanoes that are now above the ice. It's an unlikely scenario, but since it already happened in the past, it's not completely impossible. As for volcanoes hiding under a thick layer of ice, it looks like their gases would hardly make it to the atmosphere, but they would be strong enough to melt huge caverns in the base of the ice and produce a serious amount of meltwater. The West Antarctic ice sheet is wet and not frozen to its bed, so this meltwater would work as a lubricant and set the overlying ice into motion soon. The volume of water that even a large volcano would generate in this way is nothing compared to the volume of ice beneath it. So, a single eruption wouldn't make a difference. But several volcanoes erupting close to or beneath any of the western Antarctica's big ice streams would. Those ice streams are rivers of ice that take most of the frozen water in Antarctica into the ocean. If they change their speed and bring unusual amounts of water into the ocean, its level will rise. As the ice would get thinner and thinner, there would be more and more new eruptions. Scientists call it a runaway effect. Something like that happened in Iceland. The number of volcanic eruptions went up when glaciers started to recede at the end of the last ice age. So, it looks like, for massive changes, several powerful volcanoes above the ice with gases full of halogens need to get active within a few decades of each other and stay strong over many tens to hundreds of years. Antarctica stores around 80% of all the fresh water in the world, and if they melted all of it, global sea levels would rise by almost 200 feet. And then we'd have to look for a new planet to live on. But this again is an unlikely scenario. It's more likely that the eruptions under the ice will lubricate ice streams and seep water into the ocean. But it wouldn't be the end of the world. A super strong, super angry supervolcano could do it though, and it has already happened in the past. Over 200 million years ago, the world went through a major makeover with not one, not two, but 4 massive volcanic eruptions in huge pulses. The supervolcano called Camp had been erupting over and over for 600,000 years. It all happened in Wrangell, a large chunk of land that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. And it wasn't the lava or the volcanic ash that ruined the environment. The eruption made carbon levels skyrocket. The planet would never be the same again. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2 million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in Asia to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels. It made the atmosphere toasty, and the rain poured down. So the bad news is, another eruption like this could happen. The supervolcano beneath Yellowstone National Park has been sleeping for nearly 70,000 years. But if it wakes up, it would be many times more catastrophic than the eruption of Mount St. Helens in 1980. It's considered the most disastrous volcanic eruption in U.S. history. It followed 2 months of earthquakes and injection of magma below the volcano that weakened and destroyed the entire north face of the mountain. The eruption column went 80,000 feet into the atmosphere and spread ash over 11 U.S. states and several Canadian provinces. The last Yellowstone eruption was 1,000 times greater than that. The ground above Yellowstone sits on a hot spot made of molten and semi-molten rock called magma. This magma stuff flows into a chamber beneath the park, about 4 to 6 miles down, making the ground puff up like a balloon. But then, as it cools down, the ground goes back to its usual state. Volcano watchers have been keeping an eye on this for a century. They noticed the ground lift up about 10 inches around 20 years ago, but since 2010, it's been going back down. The experts say we have no big eruptions on the horizon, so doomsday isn't coming anytime soon. But there's some underground activity going on lately which keeps us interested. Since humans haven't been around to witness every little thing Yellowstone does, it's kind of tough to say for sure what's brewing down there. Yellowstone has had some epic eruptions within the last couple million years. They happen like clockwork, with gaps of 600,000 to 800,000 years between them. The last big one was around 640,000 years ago, and it basically reshaped the entire landscape, spreading ash and debris as far as Louisiana. You can still see the aftermath of the last big eruption in the Yellowstone caldera today. Experts say a massive
U.S. live there. There's also a huge amount of air cargo that passes through its international airport daily. So anytime a volcano this close to such a vital hub begins to get restless, people start paying attention. Just FYI, approximately 350 million people in the world live within the danger range of an active volcano. That means that around 1 out of 20 people live in an area at risk of volcanic activity. Alaskans probably wish that Spur's reawakening was fiction, but it's actually true. The Alaska Volcano Observatory picked up on several of these "I'm about to erupt" signs from Mount Spur. So much so that they raised the alert level to yellow, which means unrest above normal background levels. Spur erupted twice in the 90s, and it was pretty intense. If we were ranking volcanic eruptions on a scale from 1 to 10, these eruptions would rank a 6 or 7. Not that terrible, but still worth 10 to 17 million in damages. However, these numbers are nothing compared to Alaska's 1988 Redoubt eruption, another volcano that erupted and summed up a staggering $345 million in damages. Mainly because its ashes hit aircraft engines, such as the KLM 747 that lost power after all its engines went off due to the ashes. If people weren't paying attention to Alaska's unstable geology before that, well, they surely started to after it. When you think of the hazards of volcanic activity, the first thing that might possibly pop in your mind is Pompeii, Italy. Of course, that's the worst-case scenario, a city being engulfed by lava. Spur may seem innocent compared to Vesuvio, but it still took its toll. The last time it erupted in the 90s, and it threw volcanic aerosols over 60,000 feet into the atmosphere. Let's get our science straight here. Think of volcanic aerosols like liquid particles that are released into the atmosphere during an eruption. These particles are usually created when gases from a volcano, such as sulfur dioxide, combine with water and other particles that exist in our atmosphere. These aerosols can actually cool the Earth's surface since they reflect sunlight directly back into space. And that's not the worst part. It can stay in the atmosphere for several years after an eruption, causing lots of health issues. The eruption unleashed blazing fast avalanches of hot gas and ash called pyroclastic flows, along with thick, muddy floods known as lahars. Oh, and there were also the massive volcanic boulders. These rock chunks were huge, some over 3 feet long, and they blasted out from the volcano like nature's cannonballs, landing more than 6 miles away. All that volcanic heat melted part of a nearby glacier, kicking off debris flows that dammed up the Chakachatna River and created a whole new lake along the valley. Some good came out of Spur's first eruption, though. The main lesson was, volcanic monitoring pays off. The local monitoring was able to reduce the economic damage done by the eruption, especially for a city that has an intense air traffic. Spur is deemed as dormant for the moment, but it could go off anytime soon. You see, volcanoes are classified as active, dormant, or extinct, depending on how much action they're putting on. If it's still active, it's still rumbling and erupting somewhat regularly. Dormant means it's had some recent activity, but it's still lying low for now. And extinct, that's when it's been quiet for such a long time that we figure it's done for good. One of the US's most dangerous active volcanoes is Mount St. Helens. This volcano is actually responsible for the most powerful eruption in US history. Its last blast was so intense, it threw off about 1,300 feet off its summit. Basically, the top of the mountain vanished, and if you thought Mount Spur's ash cloud was impressive, St. Helens wins the competition since it launched its ashes 80,000 feet into the sky. Eastern Washington plunged into total darkness. But it wasn't just that. In a matter of 3 minutes, the eruption hurled 3.7 billion cubic yards of blazing rock and dust, enough to fill 1 million Olympic-sized pools across 230 square miles of lush forest. Actually, the earthquakes that anticipated the eruption started weeks before May 18, 1980. A ground shake of magnitude 5.0 went off, triggering a landslide on one side of the volcano. By the end of the official eruption date, 57 people had lost their lives. Nearly 7,000 big-game animals like deer and elk were wiped out, and millions of birds laid scattered on the burnt earth. Researchers don't think St. Helens will blow at the same magnitude again anytime soon, but they're keeping an eye on it, because this volcano is not exactly finished. By the way, the word volcano comes from the Roman name Vulcan, which was the Roman deity of fire, and they often happen at the meeting point of tectonic plates, which are the pieces of the Earth's surface that fit together like a jigsaw puzzle. The so-called Ring of Fire, located in the Pacific Ocean, is the world's danger zone when it comes to volcanoes. It contains between 750 and 915 active volcanoes. The largest volcano located in the Ring of Fire, also the largest active volcano in the world, is the Mauna Loa. It's over 13,000 feet high, and it's located in Hawaii. Researchers say that Mauna Loa has been erupting for at least 700,000 years. Its most recent eruption began on the 27th of November 2022, and it lasted until December 13th. It's been quiet since the 80s until it decided to wake up again. Thanks to constant monitoring by the Hawaiian Volcano Observatory, it didn't cause any casualties when it last erupted. Scientists have been investing big time on volcanic monitoring, not only to reduce economic hazards, but also to save lives. The most recent attempt has been to drill into volcanoes. Recently, a group of scientists went all the way to Iceland in one of the world's volcanic hotspots. There are around 33 active volcanoes in Iceland alone, but the one that is the most interesting to them the most is the Krafla volcano. The Krafla has erupted around 30 times in the last 1,000 years, and its most recent eruption was in the mid-1980s. The project, named Krafla Magma Testbed, or KMT for short, is hoping to advance the understanding of how magma behaves underground. The main advantage of this drilling research is predicting the risk of eruptions, but it can also help to push geothermal energy forward. I mean, can you imagine having electricity that is run by the limitless source of volcano power? The KMT team will begin drilling holes deep into volcanic ground in 2027. They're aiming at reaching over a mile into the ground. After all, it's different to monitor lava activity when it's on the surface than when it is still below ground. This will allow researchers to listen to the pulse of the Earth, according to them. They're saying this research is as revolutionary as the first time man went to the moon. Oh, and speaking of that, I was shocked to discover that volcanoes exist all throughout the solar system. Yep, other planets and moons have volcanoes too. The largest volcano in our solar system is Olympus Mons on Mars. It's a shield volcano, much like the ones that make up the Hawaiian Islands. It's about 370 miles wide. If we transported it all the way back to Earth, it would almost occupy all of Poland. Yikes.
Imagine standing in the middle of Europe 40,000 years ago. The landscape is rough, cold, and unforgiving. Fast food is scarce, and there's no internet. Suddenly, from out of the woods steps a figure, stocky, strong, and with a face that is quite unusual. This human looks similar to us, but something about them is different. Their brow is heavy, their nose is broad, and their body seems to be built to fight nature itself. Well, congrats! You've just met a Neanderthal. You might have thought that Neanderthals were basically ancient humans, but that's not really true. We come from the same genus called Homo, but we, all modern humans, belong to one same species called Homo sapiens. However, there used to be lots of human species before, and Homo neanderthalensis was just one of them. And they actually were kind of cooler than us. So what in the world has happened to them? Neanderthals lived for a long time, for about 360,000 years, across Europe and parts of Asia. 40,000 years ago, the place we now call southern Italy was sitting on top of a huge disaster, a massive supervolcano called Campi Flegrei. This big boy is huge, about 9 miles wide. That's about 10 to 20 minutes in a car to get across it all. But there were no cars then, remember? At the time, it was quiet for a while, but one day, suddenly, it blew in what became one of the biggest volcanic eruptions Europe had seen in 200,000 years. The catastrophe was so crazy that ash, gases, and debris altered the climate across the entire continent. What comes next is usually called a volcanic winter. Average temperatures drop, the sky gets darker, and life becomes even harsher than it already is. The eruption, known as the Campanian Ingembrite, caused Europe to cool by as much as 7 degrees Fahrenheit. Doesn't sound like much? Well, the drop of even 1 degree would cause winters to become harsher, causing horrible snowfall, rains, and floods. Crops would struggle to grow, leading to food shortages. The weather would go wild, too, with storms and droughts. Hey, kind of like now. Except multiply this by 7. Events like these caused some huge chaos in modern times. You can imagine what it did to the Neanderthals. But in reality, a simple volcanic eruption shouldn't destroy an entire species, right? Well, yes. The truth is, the Neanderthals were already hanging by a thread back then, and all because of us. They've been in a tough spot for a while. They lived in places that are now parts of Europe, Western Asia, and the Middle East. Modern humans, us Homo sapiens, entered Europe and were giving them some serious competition for food and shelter. Homo sapiens were sneaky dudes, better at finding food, easily adapting to different environments, and using more advanced tools. We were pushing Neanderthals out, trying to get the same resources. We literally made their extinction a slow and very unpleasant process. So, while the volcano definitely made things worse, it wasn't their only problem, and they didn't completely disappear after the eruption. Some of them hung on in isolated places, like Gibraltar, for another 12,000 years. That's because it's likely most of the severe cooling actually happened farther east, away from where the Neanderthals were trying to survive, and it didn't hit their homes as hard as we thought. In fact, the eruption may have even helped them, at least for a while. Some scientists say that the volcanic fallout might have slowed down modern humans' expansion into Neanderthal territory and gave the poor fellas a little more time to survive. So, the Campiflagre eruption was a nasty event, but it only delayed the inevitable. Campiflagre is a wild card. It's also known as the Fields of Fire. The air itself there is thick with legend. The Greeks and Romans believed this volcano was the gateway to the underworld. Even an ancient Roman poet, Virgil, mentioned this in his famous story, the Aeneid. The hero Aeneas must descend into the underworld, and this place is exactly where he starts. Back in the day, this landscape was full of Roman villas, spas, and fish ponds. The elite had the time of their lives there. What they didn't know, though, was that they were standing on treacherous ground that could go crazy at any moment. The Campiflagre is not your typical volcano. You'd imagine a single towering peak, but the landscape looks deceivingly calm, with small features popping up here and there. But if you flew above it, the sight would be insane. A gigantic circular basin, peppered with volcanic cones and craters, like scars from the Earth's violent past. The danger here lies in its subtlety. The ground beneath your feet is constantly shifting, even when you don't notice it. Every so often, the land rises, only to sink again, sometimes by several feet, as magma or gas moves beneath the surface. It's incredibly creepy. The risk is almost invisible. The Campiflagre is a massive depression formed by two colossal volcanic eruptions. One of them was the one that cooked Neanderthals, and another happened 15,000 years ago. The most famous eruption, though, happened in the 16th century, and it was horrifying. The year was 1538. For years, the people of Paswali had noticed something unsettling. Land that once sat below the waves was slowly rising. What was once the sea had become new ground. Rumblings from deep within the earth were terrifying, but had become a normal part of life. Earthquakes started in the early 1530s, small at first, but in just 8 years, they became the norm. Until one day, on September 28th, horrifying tremors shook the ground. By the next evening, as the sun dipped below the horizon, a massive crack ripped open the earth near the ancient Roman town of Trippergoli. From this gash spewed fire, smoke, and a rain of volcanic ash miles away. It was thick and muddy, likely mixed with underground water. The ground trembled as hot pumice rock was thrown high into the air. And then a new mountain began to rise from the land. This was the birth of what we now call Monte Nuovo. Eventually, things seemed to calm down, as if the earth was catching its breath. For days, things seemed quiet. Locals relaxed a bit. They began to approach the new mysterious volcano, a crater with something that resembled boiling within it. People visited it like a new attraction. But then, just days later, the disaster struck again. At night, without warning, a new mountain went wild. A blast from the southern flank hurled scoria, chunks of jagged volcanic rock, into the air. This one was fatal for 24 people. The debris found afterwards was huge and coarse. For centuries after, the only signs of life from the Monte Nuovo were small fumaroles, jets of gas seeping from the earth. But then, even those faded away. Now it's just a lush green cone, a pretty sleeping giant. But the ground near Naples, Italy, is still alive. The Campi Flegrei sits quietly for now, but it might not be for long. It's showing signs it might be waking up again. This supervolcano looks like a hellish landscape, with its boiling mud pits, geysers, and steam vents. Romans and medieval Christians once believed it was a gateway to the underworld, and who can blame them? What's spooky is that recently scientists detected unusual activity under the surface. In 2012, Italian authorities raised the alert level on the volcano from green to yellow, meaning that it needs close monitoring. There are certain changes that usually happen before an eruption. The magma below starts releasing gases, which could weaken the rock above, eventually triggering a disaster. Unfortunately, no one can predict exactly when or if it will erupt. But if it does, the consequences could range from a minor inconvenience for locals to a global catastrophe. Its last tiny eruption happened in the 16th century, and it wasn't too bad. But if history repeats itself, like it was with Neanderthals, we're all cooked. An eruption like that could lead to global cooling, crop failures, and widespread famine. Right now, a group of scientists is trying to get a clearer picture of what's happening beneath the surface. The Campi Flegrei Deep Drilling Project is working to drill a 10,000-foot borehole, hoping to check out the magma chamber up close. But at least for now, the supervolcano remains quiet, and let's hope it stays that way. These ominous rumbling sounds, the ground shaking under your feet. Wait a minute, that's my tummy. Or it might be Washington State's Mount Adams waking up. It's the largest volcano in the state by both area and volume, and it's recently started to show signs of life after staying silent for thousands of years. Scientists have noticed an alarming uptick in seismic activity around the mountain. And since the last eruption here happened between 3,800 and 7,600 years ago, humanity was still in the Stone Age at that time. This sudden chattiness has scientists, let's say, curious. The U.S. Geological Survey has hurriedly installed temporary seismic stations around Mount Adams to keep an eye on the situation. At the same time, they reassure the public there's no need to panic. Mount Adams doesn't reach the height of the better-known Mount Rainier, and still it covers a massive area, making it Washington's largest active volcano. Interestingly, records show that before September of this year, Mount Adams had experienced an average of just one small earthquake every 2 to 3 years since 1982. And then, the Cascades Volcano Observatory and the Pacific Northwest Seismic Network detected a staggering 6 earthquakes in just 1 month, September. These quakes were all rather tiny, with magnitudes ranging between 0.9 and 2 on the Richter scale. It means they were so weak you wouldn't feel them at the surface. Plus, satellite imagery confirmed there was no ground deformation in the area. Now, at the moment, the USGS keeps Mount Adams alert level at green or normal, so we shouldn't worry about the ground opening and swallowing towns and cities. But the most recent seismic blips have encouraged the agency to install additional equipment for more precise monitoring. Such an expanded network will help scientists notice even the smallest earthquakes, which will help them understand what's happening under Mount Adams. This extra equipment might also shed light on whether this recent activity is a signal of future eruptions or just a random anomaly. If Mount Adams eventually erupted, it would likely produce slow-moving lava flows rather than explosive eruptions like Mount St. Helens. After all, past eruptions have only led to lava flows that travel just a few miles from the volcano. So that's not what we'd need to worry about. A much more dangerous thing would be lahars. These are mud flows that can happen when volcanic ash, rock, and melted ice mix during eruptions. Lahars have occurred near Mount Adams without even eruptions. Rock, weakened by hydrothermal processes at the volcano's summit, suddenly broke loose, creating fast-moving, destructive mud flows. Exactly for this reason, the USGS categorizes Mount Adams as a high-threat volcano. While it doesn't erupt frequently, it still poses serious risks to nearby settlements. Another volcano we should carefully watch is Katla in Iceland. It's one of the country's most powerful and dangerous volcanoes. It last erupted over a century ago in 1918, but if it erupts again, it could be 10 times as powerful as another Icelandic volcano whose name I can't pronounce. See? That one erupted in 2010, completely disrupting air travel all over Europe. An eruption of Katla could release large amounts of sulfur dioxide, which could form sulfate aerosols in the atmosphere. Such aerosols reflect sunlight, which could even cause temporary global cooling. This phenomenon often followed catastrophic volcanic eruptions in the past. Although eruptions are common in Iceland, Katla's ash cloud would likely shoot higher into the sky and cover larger areas of Europe than that other one did. It would ground flights and negatively affect economies. If Katla erupted, it would also harm agriculture, water supplies, and air quality. In 2014, scientists noted that a large eruption could even cause a tsunami that might travel along Iceland's south coast and out to sea. But the potential impact of such a tsunami is still unclear. Katla tends to erupt on a regular schedule every 40 to 80 years, which means that another eruption is statistically very likely soon. That's why Katla remains under close scientific observation. The Canary Islands' Cumbre Vieja erupted recently in 2021, reminding people of its destructive potential. The lava flow from this eruption was devastating. It covered whole neighborhoods and flowed into the ocean, destroying more than 3,000 homes. Thousands of people had to be evacuated. But the craziest thing? Even though the damage was significant, scientists believe it could have been far worse. A massive eruption of Cumbre Vieja could have caused the volcano's entire western flank to collapse into the Atlantic Ocean, triggering a mega tsunami. This hypothetical tsunami could have potentially created waves hundreds or even thousands of feet high. They could have flooded coastlines around the Atlantic Basin, including parts of the US and Europe. Luckily, recent studies claim that a collapse of that scale is unlikely. But even though the chance of a mega tsunami is low, scientists still think it's wise to prepare for possible eruptions because there's a chance of extensive damage. The lava flows that occur at this volcano tend to be extensive and dangerous to both human life and the infrastructure on the island. If you decide to travel to Ecuador, you should be wary of Cotopaxi, one of the most active volcanoes in this country. It's been rumbling with minor eruptions since 2022. While these eruptions have been relatively small, Cotopaxi has a great potential for a major eruption, and it has scientists on high alert. If Cotopaxi erupted on a large scale, it could produce a massive ash cloud over 12 miles high, threatening the lives of around 200,000 people in the neighboring area. A serious danger is Cotopaxi's snow-capped summit. It would melt super rapidly in a major eruption. It could lead to destructive floods and landslides that would flow down the mountain and potentially reach populated areas. This combination of volcanic activity and glacial floods makes Cotopaxi a high-risk volcano. A powerful eruption could occur soon, or it could be years or even decades away. But monitoring efforts are in place to catch any warning signs. The next volcano we should watch out for is already infamous, Mount Vesuvius. Its catastrophic eruption in 79 CE destroyed the Roman cities of Pompeii and Herculaneum. Its last eruption occurred in 1944, but Vesuvius remains highly active and poses a great risk to nearby Naples, one of Italy's largest cities. A large eruption would threaten over 3 million people. Many of them live in the vicinity or even directly on the slopes of the volcano. If Vesuvius erupted, it would be an explosive event, with ash, rocks, and volcanic gas ejected at extremely high speeds. And even though such a destructive event isn't expected for a few hundred years, Vesuvius remains one of the world's most closely watched volcanoes. After all, it has a real potential to cause catastrophic damage in a densely populated area. Then we have Popocatépetl, often called El Popo. It's one of North America's tallest active volcanoes, which lies about 40 miles from Mexico City. Exactly this proximity to a metropolitan area with a population of 22 million people makes Popocatépetl especially hazardous. A large eruption could send a massive ash cloud over Mexico City, causing widespread disruptions. Ash could clog the city's drainage systems, contaminate water supplies, and even cause power outages by short-circuiting electrical systems. Plus, lahars could rush down the volcano, reaching nearby towns. Popocatépetl has been showing near-constant seismic activity since the early 2000s, and smaller eruptions are pretty common here. In early 2024, there were 13 recorded minor eruptions, which alarmed nearby towns. At the same time, volcanologists consider such eruptions normal for Popocatépetl. While talking about super dangerous volcanoes, we can't skip Yellowstone National Park. It houses one of the world's largest supervolcanoes. Its last massive eruption occurred about 640,000 years ago. But if this monster were to erupt today, the impact would be much more devastating for the entire planet. States closest to Yellowstone, including Montana, Idaho, and Wyoming, would be most affected, likely experiencing disastrous pyroclastic flows. These flows, which are made of a dangerous mix of lava, ash, and gases, can obliterate everything in their path. Large parts of the country would also be blanketed in volcanic ash, over 3 feet in some areas. On a global scale, an eruption at Yellowstone would send tons of ash and gases into the stratosphere, potentially blocking sunlight and causing global temperatures to drop for a few years. This would disrupt agriculture, collapse transportation systems, and create food shortages on a massive scale. Still, even though there's a popular myth that Yellowstone is overdue for an eruption, geologists clarify that this isn't true. Volcanoes don't follow precise timetables, and the activity at Yellowstone doesn't indicate an imminent eruption. So yeah, that's good news.
It's the 15th of January, 2022, 4:47 p.m. local time. It will start any moment. Here, do you feel these jolts? The South Pacific is about to experience one of the most powerful volcanic eruptions ever recorded by modern instruments. The eruption begins at Hunga Tonga Hunga Ha'api, an underwater volcano in the Tongan archipelago. The eruption itself is enormous. Its volcanic explosivity index is at least VEI 5, with the maximum being 8. It's as powerful as such historic catastrophes as Mount St. Helens in 1980 and Mount Vesuvius in 79 CE. The eruption releases a staggering 2.4 cubic miles of volcanic material and sends over 150 million tons of water vapor into the stratosphere. This amount of water vapor would have been enough to fill 58,000 Olympic swimming pools. Additionally, the eruption generates the fastest underwater currents ever recorded and triggers large tsunamis that struck areas as far as Peru, more than 6,200 miles away from the volcano. And it takes at least 4 lives, with even more missing. But the craziest thing is that just before the eruption, 15 minutes ahead of time, there was a kind of warning. But as it often happens, people simply missed them. 2 seismic stations, about 466 miles away from the volcano, which is pretty far for this kind of thing, picked it up. They figured out it was a Rayleigh wave, which is a type of seismic wave that moves along Earth's surface. This wave was caused by a fracture in the ocean floor, where magma and seawater started to interact under a lot of pressure. That's likely what triggered the eruption. The crazy thing is that normally, volcanic seismic signals are pretty small and can only be detected close to the volcano. But this Rayleigh wave traveled way farther than usual and was much stronger. It means there had to be a massive amount of movement going on beneath the surface before the eruption. While people on the ground didn't feel it, those distant sensors picked it up. And this discovery is great for identifying volcanic threats earlier in the future and for improving early warning systems. If scientists can detect these seismic precursors, they could give a heads up before an eruption happens. That would give people time to evacuate and reduce the chances of injuries or property damage, especially for underwater volcanoes like this one, which can also trigger fatal tsunamis. Now, the eruption was big, but its impact was mostly contained. However, This discovery underlines how important seismic data is for predicting and preparing for these disasters. Even though this precursor wasn't used to issue a warning during this eruption, the idea that we could use this kind of information in real time during future eruptions is really promising, especially for underwater eruptions, which apparently might give us more warning time than we thought. Even though we wouldn't have been able to hear that precursor warning signal, there is a sound so loud it could actually finish you. And while such sounds are incredibly rare, the loudest noise ever recorded was indeed fatal to those who were close enough. On 27 August 1883, the eruption of the Krakatoa volcano in Indonesia created the loudest noise ever measured. It's thought to have been an astonishing 310 decibels at the source. To put this in perspective, a hand drill produces the sound of 98 decibels. The noise produced by a jet engine measures 140 decibels. And the sound of 180 decibels is capable of destroying your hearing tissue. So, the sound Krakatoa produced reached more than 170 decibels at a distance of 100 miles. And sailors aboard a ship just 40 miles from the eruption had their eardrums burst from the sound. The explosion's reverberation was so powerful that it was heard 3,000 miles away. In fact, at a farm in Alice Springs, Australia, over 2,200 miles away, sheep farmers reported hearing what they thought were gunshots. The sound from Krakatoa traveled around the world multiple times. Although no one heard the explosion beyond 3,000 miles, spikes of atmospheric pressure were recorded in places as far away as Canada and England. Those must have been the sound waves produced by the eruption traveling around the globe. Sound above 150 decibels can potentially cause life-threatening harm. In particular, sounds between 170 and 200 decibels can result in lethal conditions, including burst lungs. Anything over 240 decibels could cause fatal injuries, and you don't even want to know what those are. I'll just say that those sometimes happen to cartoon characters, but rarely to people. The scientific explanation behind this is that sound is essentially a wave of pressure, which can travel through both solids and liquids. And, in the case of an incredibly loud sound, pass right through the human body. If the pressure from such a sound is high enough, it can rupture eardrums and internal organs, causing significant and often fatal damage. Now, you probably know how volcanoes sometimes have small earthquakes before they erupt. Well, they often produce this weird sound called a harmonic tremor. The sound kind of hums, and the frequency of the hum gets higher and higher until it suddenly stops just before the volcano erupts. The sound has been recorded at a bunch of volcanoes around the world. But the thing about Redoubt Volcano in Alaska is that its tremor is so intense, people can actually hear it. It's like the volcano is letting out this crazy scream right before the eruption. According to a geophysicist at the University of Washington, the frequency of Redoubt's harmonic tremor is so high that it is barely perceptible as a low bass hum, and that's at its highest pitch. All because the pitch of Redoubt's tremor exceeds that of any other recorded volcano. It questions the limits of the existing models used to explain these phenomena. That's why researchers had to propose a new model to account for these unusually high-pitched tremors. Most volcanoes produce sound when magma bubbles vibrate as they rise through cracks in Earth's crust. But in the case of Redoubt, scientists believe that the harmonic tremor and associated earthquakes occur when magma is forced through a narrow opening under immense pressure. The thick magma sticks to the rock surface inside the conduit, a channel or pipe that carries magma from a reservoir or chamber to the vent. As the pressure builds, the magma moves upward. This makes it stick again until the pressure forces it to move once more. These sudden movements cause small earthquakes, which, as the pressure increases, occur more rapidly and blend into a continuous rising noise. So it's actually the rocks making the sounds. This new model is important because it could help scientists better understand the eruptive cycles of volcanoes like Redoubt. It could also serve as a limited early warning system. By the time Redoubt began to scream like this, the volcano had already been erupting for a few days. So the tremor might only provide a few minutes or hours of warning before the next explosion. The harmonic tremor at Redoubt reaches an extremely high frequency, then falls eerily silent before the volcano erupts again. This pause occurs when the earthquake activity slows down and the two sides of the fault slip smoothly against one another. Maybe that's when even earthquakes can't keep up anymore. The new model may also apply to other volcanoes, such as the Soufriere Hills volcano on the Caribbean island of Montserrat. The research team is now planning to investigate why the pressure at Redoubt is concentrated in one specific spot. To move ahead in their research, the scientists have created 2 recordings of Redoubt's seismic activity. The first, a 10-second recording, compresses about 10 minutes of seismic sounds and harmonic tremors, sped up 60 times. The second, a 1-minute recording, condenses roughly an hour of activity, including more than 1,600 small earthquakes that had occurred before Redoubt's first explosion with harmonic tremor. These recordings could provide crucial insight into the dynamics of volcanic eruptions and the signals that precede them.
Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campi Flegrei erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campi Flegrei has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campi Flegrei is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news. because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared.
The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates, but so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agun, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano. Phew, you can finally send that last report for the day and breathe out. The weekend is around the corner. But just when you're about to hit send, you're alarmed by the low rumbling under your desk. Is it the light rail passing by? Unfortunately, that's not the case. It's a volcano speaking. What, here? In Arizona? That's right, the ground keeps shifting under Arizona, reminding us that Earth is alive. No panic though. Let's arm ourselves with some context. 20 American states have extinct, active, and dormant, currently sleeping, volcanoes. Among such states, you can find California, New Mexico, Nevada, Utah, and Colorado. On the bright side, Arizona's volcanoes are dormant at the moment, but it doesn't mean they won't go off in the near or not so near future. Now, how about traveling to Arizona to check the traces of its active volcanic past? They dot the desert landscapes of this state like spots dot a Dalmatian. There are entire volcanic fields southwest of Phoenix, east of Douglas, near Flagstaff, north of Kingman, and near the Mexico border. The most worrying thing about these fields is that even though they're not active at the moment, eruptions in this region might happen every 1,000 years or so. Well, the time seems to be up. The last powerful and destructive volcanic eruption occurred around 1,000 years ago at the Sunset Crater. Oh, this place is worth paying more attention to. And we will, but a bit later. First, we have to talk about hotspots. No, not that place where you can surf the web. In our volcanic context, a hotspot is a place where insane amounts of heat melt the overlying crust, Earth's thin outer layer, and form volcanoes. This heat rises from the mantle, which is located between our planet's dense, superheated core and the crust. Want to see an example of this type of volcanism? Welcome to the Hawaiian Islands. The Big Island has its active volcanoes because, at the moment, it's situated on top of the Hawaiian hotspot. The older Hawaiian Islands were once there too, but later they drifted off towards the northwest. It happened because that's where the oceanic crust on top of which they sat, namely the Pacific Plate, moved. Now, look at the world's ocean basins. Yes, they're literally dotted with islands that sit on top of hotspots, like Hawaii, Iceland, Samoa, the Galapagos. Those are probably the most famous examples. But don't think that continents can't host hotspots. They can, but those are far less common. One of the most famous continental hotspots is, I bet you know it. Yep, the one beneath the Yellowstone caldera. By the way, the caldera is a vast volcanic crater, especially one formed as a result of a massive eruption that led to the collapse of the mouth of a volcano. The Yellowstone hotspot is basically the creator of Old Faithful and the rest of the hot springs and mud pots for which the national park is famous. Speaking of Old Faithful, let's make a small detour and pay more attention to this wonder of nature. It's one of the most well-known geysers in the world. People have been coming from all over the globe to see it for more than a century. The cool thing about this geyser is that the likes of it can only form under very specific conditions. That's why they're pretty rare. Magma under the surface superheats pockets of underground water. The pressure there keeps growing until it eventually pushes the water upward with immense strength. A certain volcanic rock with a high silica content lines the tunnel through which this water escapes. Basically, it creates a unique pipe that can withstand unbelievable pressure and heat created by the water erupting above the ground. Old Faithful was the very first named geyser in Yellowstone. If you come to visit it expecting the thing to erupt every hour on the hour, you're gonna be disappointed. On average, Old Faithful erupts every 91 minutes or so, which isn't that bad either. Plus, you can download a special app which will provide you with the approximate time of the next eruption. But be very careful while visiting and stay away from the site. The water erupting from the powerful geyser reaches 204 degrees Fahrenheit. The steam is even more scorching, up to 350 degrees Fahrenheit. It's hot enough to bake a cake. But let's get back to our volcanic hotspots. Scientists still don't clearly understand why there aren't many hotspot volcanoes on continental crust. One reason might be that the continental crust is much thicker than the oceanic crust, which is about 4 times as thick on average. Another reason could be that most of Earth's crust, about 2/3 of it, is oceanic. This means that there's less continental crust for hotspots to form under. Now, I bet those of you living in Arizona will appreciate the following info. We'll talk about a volcanic field right in the heart of this state, the San Francisco Volcanic Field. That's a massive area filled with over 600 volcanoes. Yes, they're mostly small, but it doesn't make them any less impressive. They're scattered across 1,800 square miles in northern Arizona, a giant territory. Interestingly, scientists are still debating about whether this volcanic field is actually sitting on top of a hotspot. But one thing they agree upon: the volcanoes in this area get younger as you move east. And this pattern matches up with the North American plate moving west over what could be a stationary hotspot beneath the surface of our planet. Cool, huh? The volcanic hullabaloo in that area started around 6 million years ago. So, in geological terms, it's relatively young. As for the most recent eruption, it happened less than 1,000 years ago. The Sunset Crater, which I mentioned before, the one near Flagstaff, is the most famous vent from that eruption. The Sinagua people had to leave their homes at Wupatki Pueblo because of the eruption. That site is now part of the Wupatki National Monument. There, you can see how people lived in this volcanic region many years ago. If you go to explore this area, you'll notice that most of the volcanoes there are basalt cinder cones, small and steep. The Colorado Plateau has quite dry weather conditions. That's why the volcanoes haven't worn down much. Some of the best examples of those cones, like this one, called the SP crater, still look like they appeared yesterday. But look around. It's not just cinder cones. The San Francisco volcanic field also has a stratovolcano, as well as some lava domes that formed from volcanic rocks with more silica than basalt you can find in places like Hawaii. It means they're thicker and don't flow as easily. Anyway, the stratovolcano is going to be one of the most epic sights you'll come across while exploring this volcanic field. Well, not the stratovolcano itself, but the San Francisco peaks, the remains of that giant formation. They stand tall at more than 12,600 feet. That's 4.5 Burj Khalifas placed on top of one another. It makes the peaks some of the biggest landmarks in northern Arizona. They're not only stunning, but also sacred to the Native American people who have lived in the area for many generations. Now, unlike those super active volcanoes in Hawaii, the San Francisco volcanic field takes its time, thousands of years between eruptions. But you shouldn't relax just yet. Geologists say another eruption is likely to happen one day. It will probably occur in the remote eastern part of the field, away from big towns. Phew! And if that next eruption is anything like the one that formed Sunset Crater, it would be quite the show. Lava fountains and rivers of lava flowing. At the same time, the next eruption might not happen for centuries, maybe even millennia. Until then, the San Francisco volcanic field will remain a hidden gem of volcanic history, waiting for its next fiery performance. The story of Pompeii is complete chaos as is, but to add a little fuel to this fire, we dug up some groundbreaking facts, and I mean that quite literally. Hear me out. What if it wasn't the scorching sea of lava that destroyed the city of Pompeii, but rather an earthquake that happened during the volcano's eruption? Rewind to over 2,000 years ago. The year is 79 BCE. It was around 1 o'clock in the afternoon when Mount Vesuvius decided to erupt. Pompeians were going on with their normal daily routines when lava started taking over. The flow of lava was so quick that most people didn't have anywhere to run. The disaster took the lives of around 2,000 people. The lava covered most of the city, which then turned everything to ashes. Pompeii was only discovered during the 16th century of our Common Era, when an architect commended a dig to divert a river. It's a very well-studied site nowadays, but something unusual recently caught the researchers' attention. Scientists were excavating a site called the House of Painters at work. They were examining a couple of skeletons when they saw something weird. The skeletons probably belonged to two men around the age of 50. The analysis showed these men had survived the first surge of lava in the city. But they didn't make it out due to this second unexpected part, the earthquake. The men probably took shelter at the House of Painters at work, but the walls crumbled down when the earthquake hit. The men were found in a protective posture, like they were trying to shield themselves from something that was going to fall above their heads. Plus, these skeletons were not found under the layer of volcanic ash, but on top of it, proving that they really did survive Vesuvius's sea of lava. It turns out this is not as rare as it seems. A volcanologist explained that the seismic activity during the eruption really made things worse in Pompeii. He said that this seismic chaos probably influenced the desperate choices of a lot of Pompeians in their final moments. This is not the first time the world heard of a possible earthquake in Pompeii. A guy named Pliny the Younger, who escaped the disaster and witnessed the whole thing, beat these scientists to it in his famous letters. Pliny the Younger was a lawyer and an important person back in ancient Rome. He was an eyewitness to the whole Pompeii disaster, and he wrote in one of his letters that the eruption was followed by a trembling of the earth. Researchers do agree that something never added up. Pompeii is known to have really well-preserved skeletons since the ashes kind of played an important role in preserving them. But the buildings were in horrible shape, making it hard to reconstruct the entire city as it once was. Pompeii was indeed one of a kind. It was one of the most vibrant and lively cities of the ancient Roman Empire. The city was huge. It could have been home to as many as 30,000 people in its heyday. The House of Fawn, for example, was a clear example of how rich Romans lived their lives in Pompeii. It was a huge house that even had 2 gardens inside, taking up the entire block. They looked like they were made of white marble, but it was actually painted stucco. It was clear to researchers that only aristocrats lived there. Then there was this famous forum. This is where most of the administrative part of the city life happened. It was made up of a lot of different buildings, like the Basilica, a hotspot for political and civil meetings, the Macellum, which was a market, and several temples. If we were visiting this back in the day, we'd see a bunch of men dressed in tunics. A few select ones would wear togas, those heavy white pieces of draped cloth that look like bed linen wrapped over the body. Togas were mainly used on special occasions since they were costly, hard to wash, and considered a traditional costume. Representatives running for office would use it during their campaign run so that commoners would identify them as candidates. One can't forget about the Villa of the Mysteries. Cool name, huh? It was called that way because of some mysterious frescoes found inside of it. Modern-day archaeologists still haven't figured out what the scenes painted are trying to depict. Probably some type of ritual or ceremony. By the way, a villa is simply a large suburban Roman-style house. It's not necessarily a super posh place where the rich and beautiful live. It's usually located on the outskirts of town, near the city's walls. The Villa of the Mysteries one in particular was found astoundingly well preserved in modern archaeological excavations. It even had a manufacturing area inside of it, like its own little industry. It was common for richer Romans to own big farmlands, like olive gardens, for example. So they would also build a processing station inside their villas to extract the oil and package the whole thing. The amphitheater was where some of the richer men paid to put on gladiator fights for the rest of the town. It was built around 70 BCE, and it was one of the oldest amphitheaters of the world. It was even older than the Colosseum in Rome. This huge building could fit around 20,000 spectators at once. The seating was arranged by social class, so you could easily spot who was a member of the nobility. And in case you're wondering why it was shaped like a weird egg, it's because that was the shape that allowed for an unobstructed view wherever you were in the crowd. As every other Roman city, Pompeii also had some famous baths. Since not every house had access to plumbing back in the day, most people didn't shower in their homes. That's why so many Romans would use public baths, usually at the end of the day, to clean themselves. But make no mistake, this wasn't just a place for bathing. It was a cultural hotspot. The baths were made up of many different rooms. The first one was like a locker room, where people would keep their clothes and personal belongings. This is where the upper and lower classes mingled together. Someone's class could easily be identified by their clothes and jewelry. The amount of gold and silver worn back in those days is nothing compared to what most people wear today. Usually, the rich folks would leave someone to take care of their belongings while they went and took their bath. Because yes, it could happen that stuff went missing while chilling and relaxing. The big focus on self-care nowadays was already a thing for ancient Romans. It was common that before taking a bath, olive oil was rubbed all over the skin. They would scrape off the dirty skin with a strigil. That may sound weird, but also extremely pleasing. The baths had rooms for massages. Some of them had reading rooms, and even courtyards for some healthy exercise. Oh, there was even a natatio, or swimming pool if you're not fluent in Latin. After all, it was the Romans that said, "A healthy body is a healthy mind." The bakeries! Bread was one of the main components of Pompeian diet, so much so that there were around 30 bakeries in the city. Bread was freshly made from scratch every day. In a special area of the shop, the corn or wheat was ground, and mules would circle around to keep the mills going. The funny thing about Pompeians is that they like to cover the exterior walls of buildings with paintings, much like graffiti nowadays. Their paintings, usually frescoes, used to depict what daily life was like in the city. Ancient Romans were very outdoorsy people, so coloring their walls seemed like a good option for them. A lot of houses had frescoes inside of them too, to make up for the lack of windows. The paintings gave the house owners the illusion of more space if the painting was of, let's say, a garden, for example. The last time this volcano erupted was about 500 years ago, but recently, small tremors have grown really frequent, to such an extent that scientists have been recording more than 1,000 a month. I'm talking about the Campi Flegrei supervolcano in Italy. At one point, just a few weeks ago, the area was rattled by a 4.4 magnitude earthquake with 150 tremors in just one night. It was the strongest earthquake in over 40 years. A lot of locals spent the night in their cars, but in the morning, the shakes were followed by another earthquake, a bit weaker with a magnitude of 3.6. So, is Italy in danger? Well, the quake itself wasn't big enough to cause serious damage, but it evoked a lot of panic. At the moment, local authorities are working on grandiose emergency plans. If worse comes to worse, they'll have to evacuate hundreds of thousands of people. One of the reasons is the proximity of this area to Naples with more than 3 million inhabitants. At the moment, they're even considering an option of paying people to leave their homes. Right now, schools remain closed in the Campi Flegrei area. The authorities are allocating more than 500 million euros to ensure the safety of buildings and constructions in the area. A yellow alert is still in place in the region where 80,000 people live. There's the so-called red zone, which is the most dangerous area. There are 1,250 houses in this red zone, and all of them will be at high seismic risk if an eruption begins. Plus, more than twice as many will be at medium risk. Italy is a country prone to seismic activity, and Pozzuoli is a densely populated area that is located on one of the most dangerous supervolcanoes in Europe. Campi Flegrei has 24 hidden underground craters and dwarfs the better-known Vesuvius. Yes, the very volcano that wiped the ancient Roman city of Pompeii off the face of the earth in 79 CE. This city thrived near the base of Mount Vesuvius at the Bay of Naples. In the time of the early Roman Empire, 20,000 people lived in Pompeii. They were merchants, manufacturers, farmers, and others. The soil in the region was rich and fertile, so there were lots of orchards and vineyards. Strangely, no one knew that this black earth was the legacy of an earlier eruption of Mount Vesuvius. The area was a favorite summer destination for rich Romans. Sadly, at noon on August 24, 79 CE, all this prosperity came to an end. The peak of Mount Vesuvius exploded, sending a 10-mile-high mushroom cloud of ash and pumice into the stratosphere. For the next 12 hours, the eruption was wreaking havoc on the city. Volcanic ash and a hail of pumice stones, some of which were 3 inches in diameter, showered Pompeii. It forced the city's occupants to flee in terror. Around 2,000 people holed up in stone structures and cellars, paralyzed by fear. They hoped to wait out the eruption. Who knows? Maybe if they had decided to leave the city immediately after the beginning of the eruption, they would have had some chances to survive. A westerly wind protected the city from the first stages of the eruption. But soon, a giant cloud of hot ash and gas rushed down the western slope of Vesuvius. It engulfed the city, burning everything in its way. This disastrous cloud was followed by a flood of volcanic mud and rock, which completely buried the city. As if the volcano was making sure no one would survive, a cloud of toxic gas poured onto the city, finishing the lives of a few survivors on August 25th. A flow of rock and ash followed. It collapsed roofs and walls and turned the city into a giant cemetery. When a supervolcano erupts, the consequences are usually catastrophic. Supervolcanoes have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually located over hotspots and appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes, all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. The most recent super eruption happened in New Zealand. Well, when I say recent, I meant around 26,500 years ago. That's when a supervolcano beneath the surface of Lake Taupo spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up into the air at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Taupo volcano didn't simply go off like many others. At first, everything was going as usual. Tons and tons of pressurized magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first portion of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground. Thousands of tons of lava, rocks, and ash flew high into the atmosphere. The unusual pattern of Taupo still confuses scientists. The Indonesian eruption at Toba caldera 75,000 years ago was the largest eruption in the last 2 million years. Experts estimate that the eruption could have released hundreds of thousands of tons of sulfuric acid, which might have even caused a several-degree cooling of the planet's surface. But nowadays, the impact is hard to detect because of glaciers that covered the ground afterward. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced any super eruptions. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperatures made the volcano blow up with a deafening boom. It was clearly heard 3,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. It only had a volcanic explosivity index of 6. Then, there's also Mauna Loa. It's a shield volcano, which means it won't produce explosive eruptions, but its sheer size makes this monster of a volcano extremely dangerous. At the moment, the volcano seems to be at peace with its surroundings. Research equipment doesn't show any signs of activity on Mauna Loa, but if Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places like Captain Cook very fast, in a matter of hours. The last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where the University of Hawaii is located. Luckily, people had a few weeks' warning to get ready for the disaster. Over its recorded history, Mauna Loa has been erupting pretty regularly, almost every 6 years. On the bright side, big island volcanoes including Mauna Loa aren't really very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes are formed by very fluid lava. It travels way farther and forms much thinner flows than the lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So, if Mauna Loa erupts, there probably won't be ash clouds or tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast.
So this huge volcano, everyone thought to be extinct, woke up and spat out a black ash cloud 50 miles high. That's about 9 times as tall as Mount Everest. Located in what is now Indonesia, the powerful Krakatoa had caused huge tsunamis that rocked over ships as far away as South Africa. It also changed the temperatures around the world for several years. The volcanic island of Krakatoa in the Sunda Strait was likely born thanks to another major eruption several centuries ago. It hadn't erupted for at least 200 years before 1883. So the first tremors and blasts in May of that year came as a total shock to people living nearby. Then ships sailing through the busy water passage started reporting clouds of ash above the volcano. It went quiet again for a while, but they could still see ash above it. The eruption culminated at the end of August. It was so powerful that it shattered the island into fragments. Witnesses heard the sound produced by it in Australia, around 3,000 miles away. They described the noise as the roar of heavy cannons. Some say it was the loudest sound ever heard. During the next 5 days, the pressure wave from the eruption traveled around the globe 3.5 times and was seen on barographs on different continents. Hot avalanches of ash spread down the volcano as far as 25 miles away at crazy speeds. They ruined the surrounding islands and took 36,000 lives. Tens of thousands more drowned in tsunamis that happened after the volcano had collapsed into the caldera. Over 100 coastal villages on Java and Sumatra were completely wiped out. All this made the waking up of Krakatoa one of the most devastating in the entire recorded history. The Earth's crust is like a giant puzzle, made up of massive pieces known as tectonic plates. These plates are constantly sliding against each other over the mantle, which is the molten layer beneath. Indonesia is right in the middle of the so-called subduction zone. Here, the Indo-Australian plate collides with part of the Asian plate as it moves northward. As the oceanic plate dives down, it gets heated up, and you've got the perfect recipe for a volcanic hotspot. Krakatoa had 3 peaks, each serving as an exit door for a massive magma chamber beneath it. During a previous eruption, debris blocked one of these exits, and the pressure built up beneath. When Krakatoa finally blew its top, the blast split the magma chamber wide open. The eruption led to a so-called volcanic winter. Krakatoa had sent 6 cubic miles of rock, ash, and debris into the atmosphere. They created a thick veil that surrounded the Earth. The particles scattered sunlight, and the troposphere below cooled down. The effect stayed strong for several years. The northern hemisphere experienced colder than average temperatures, and in some regions, summer temperatures didn't rise to typical levels. Southern California received a record amount of rainfall in the months following the eruption. The sky became darker in different parts of the world for years afterwards. The sunsets, for many months, turned into a spectacular show of red and orange. One astronomer supposed it was the source of the inspiration for The Scream by Edvard Munch. The painting shows exactly what the sky over Norway looked like after the eruption. It also produced a rare type of halo called Bishop's Ring and a volcanic purple light at night. For several years after Krakatoa had blown up, the moon looked blue and sometimes green. That's because some ash clouds were full of particles large enough to scatter red light, only letting other colors pass. Someone even witnessed lavender sun and night-shining clouds. Krakatoa became the first scientifically well-recorded and studied eruption of a volcano. Between the moments the first clouds of ash were seen by a ship passing by and the disastrous eruption, scientists managed to organize geological expeditions. They studied the volcano and gathered samples of volcanic rocks. It became useful for understanding volcanic activity. Krakatoa was sleeping tight until the 1920s, when some locals noticed a column of steam and debris spewing from the collapsed caldera. Within weeks, the rim of a new cone sprang up above sea level. After a year, it was a small island named Child of Krakatoa. It continues to erupt, but fortunately without serious consequences so far. In April of 1815, Mount Tambora unleashed a massive eruption, wreaking havoc on the Indonesian island of Sumbawa. It destroyed homes and claimed 10,000 lives. Another 80,000 perished because of diseases that spread in the aftermath. The following went in history as the year without a summer. Cold, wet conditions wrapped Europe and North America in an unexpected chill. It became the coldest in at least 250 years. In the summer of that year, the temperatures dropped the most. Crops didn't grow, livestock didn't survive, and famine took over Western Europe and North America. New England had snow and terrible frost in the summer months. Food prices went up. Oats for horses became a luxury. Some people say it even inspired the invention of the bicycle in 1817. Scientists used early data and climate models to see if it was all because of the Tambora eruption. They compared the data to similar years. They showed that precipitation was around the same, but the temperatures were much warmer. When they introduced the volcano into the scenario, they got the exact data for the year without summer. They say that a powerful volcanic eruption like that one increases the likelihood of extreme cold by up to 100 times. The explosion of the Toba supervolcano on the island of Sumatra around 74,000 years ago became the Earth's largest volcanic eruption in 28 million years. Parts of Indonesia, India, and a slice of the Indian Ocean got a cozy blanket made up of 6 inches of volcanic debris. It spat out a volume of rock comparable to almost 3 million Empire State Buildings. The crater it had left behind is still seen from space. All the ash and volcanic gases that sprang into the atmosphere because of the eruption partially blocked the sunlight. A severe volcanic winter began and lasted for 6 to 10 years. Some anthropologists see a connection between the Toba eruption and how limited modern humans are when it comes to genetic variety. Around 74,000 years ago, exactly when the Toba erupted, there was a population nosedive. That's why all modern humans trace their roots back to a tiny group of survivors. The Toba catastrophe theory proposes that most early humans in Europe and Asia didn't make it through the post-eruption climate chaos. Instead, a lucky, genetically limited bunch found their safe haven in Africa. But archaeological and paleoclimate records disagree with this theory. Benjamin Black from Rutgers University and his team set out to crack the code and discovered a hidden paradox. Maybe we were peering through the wrong climate lens. They ran 42 different climate model simulations, varying the magnitude of volcanic emissions, time of year of the eruption, background climate state, and eruption column height to see what climate disruptions the Toba eruption might have caused. There was a significant drop in temperatures in the northern hemisphere in the first year after the event, up to 18 degrees Fahrenheit. The southern hemisphere, where the early humans were settling, didn't go through a rough cooling that could have affected them all. The most significant eruptions that can seriously change the world's climatic patterns come from supervolcanoes like Yellowstone or Mount Toba. Luckily, these erupt very rarely, about every 100,000 years or more. Still, climate scientists study volcanic eruptions to understand and explain short periods of cooling in the history of our planet. Every few decades or so, a volcanic eruption lets out a substantial number of particles and gases. Some of them will block enough sunlight to start a brief global cooling period. Nothing like the real volcanic winter, but still felt across the globe. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60, but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. Whoa! Earth's surface is shaking. Long cracks split the ground open. Lava rivers are rapidly flowing down the slopes. Deafening noise is filling the air. Rocks and other debris are flying high up. Clouds of volcanic gas and ash cover the sky. Now, this is not a plot of a blockbuster disaster movie. It's what happens when supervolcanoes decide to erupt. But this is likely not the scenario that will take place when the world's largest volcano, Mauna Loa, decides to finish its long, long nap. In 2021, scientists were sure it would happen soon, but so far, nothing. The volcano's seismicity keeps increasing and then going back to normal. But you never know when this giant will finally come back to life. That's why experts have been monitoring geological activity on Hawaii's largest island for quite some time. The Big Island of Hawaii is made up of 5 volcanoes, including the most active on the planet, Kilauea, and the largest, Mauna Loa. This gigantic thing makes up almost half the landmass of the island. And what lava Kilauea emits in one day, Mauna Loa could spew out within 20 minutes. That's what it did in 1984. While Mauna Loa's smaller sibling has been throwing tantrums for a while, the giant has been slumbering ever since its last eruption. But very recently, the Hawaii Volcano Observatory has recorded more than 200 mini-earthquakes below Mauna Loa. It likely means an increased flow of magma down there. Good morning! The volcano might be waking up. Or not. If Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places, like Captain Cook, very quickly, in a matter of hours. In 1984, the last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where a campus of the University of Hawaii is found. Luckily, people had a few weeks' warning to get ready for the disaster. These days, locals have special go bags ready with the most important stuff, including documents and money. Such precautions can come in handy in case of an emergency evacuation. Even though most Mauna Loa eruptions have so far only affected the summit area, several of them sent lava all the way down to the ocean. And you never know how powerful the next eruption will be. Now, what is the highest mountain on Earth? Mount Everest, you say? Well, it depends. From seafloor to the summit, Mauna Loa is 1,000 feet taller than the famous Himalayan peak. The volcano is so big, it makes the Pacific plate it's sitting on literally slump under its weight. Scientists say that when this monster of a volcano erupts, the volume of lava coming out per unit will be life-threatening. Over its recorded history, Mauna Loa has been erupting regularly, almost every 6 years. And even though the last eruption of the volcano occurred about 40 years ago, scientists are certain it'll happen again. Now, remember the scene I showed you at the beginning? Well, you can relax. It's not likely to happen with Mauna Loa. The thing is, big island volcanoes, including Mauna Loa, aren't very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes get formed by very fluid lava. It travels farther and forms much thinner flows than lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So if, or should I say when, Mauna Loa erupts, there probably won't be ash clouds and tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. Using theoretical vent maps, experts from the Hawaii Volcano Observatory have made charts of possible lava flows. They're kind of worried about earthquakes clustering at high rates. It likely means that lava is on the move under the surface. 500 to 600 earthquakes per day are a serious reason to be on high alert. On the other hand, it doesn't necessarily mean a disaster or inevitable eruption. Around a decade ago, several earthquakes that happened at the same time signaled that something was happening under Mauna Loa. But an eruption didn't occur. Instead, half the volcano shifted a bit to the south. This way, it probably gave more room to magma, so that it had enough space to stay beneath the surface. Now, let's get back to the catastrophic eruption we saw at the beginning of the video. That's what often happens when a supervolcano erupts. Those are volcanoes that have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually found over hot spots. Supervolcanoes can produce super eruptions, and when they do, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes get formed when gigantic volumes of scorching hot magma are trying to escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. That's why a huge pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more magma is trying to get to the surface, until, bam, a super eruption occurs. The most recent super eruption happened in New Zealand. Well, when I say recent, I mean around 26,500 years ago. Nah, I wasn't around then. That's when a supervolcano beneath the surface of Lake Tahoe spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Tahoe volcano simply didn't go off like many others. At first, everything was going as usual. More than 200 square miles of magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first part of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground, and thousands of tons of lava, rocks, and ash flew high into the atmosphere. But the age of supervolcanoes isn't over. The most infamous of them all is probably the one in Yellowstone National Park. This giant handles at least 3 mega-powerful eruptions, and who knows how many smaller ones. If this monster erupted anywhere as strongly as it did 2.1 million years ago, it would spit out more than 588 cubic miles of red-hot material. You can probably picture it more vividly if I tell you that this volume is comparable to 65 million Capitol rotundas in Washington, D.C. piled together. Wow. Anyway, scientists are sure that Yellowstone doesn't present any danger these days. For an eruption to happen, magma inside must be at least 50% molten. With the Yellowstone caldera, this number is just 5 to 15%. But of course, Yellowstone isn't the only supervolcano on our planet. There's also New Zealand's Tahoe you already know about, Japan's Airi Caldera, California's Long Valley, Indonesia's Toba. Any of them can one day produce a super eruption. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced anything like a super eruption. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperature made the volcano blow up with a deafening boom. It was clearly heard 2,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle. It's way thicker. And this is the core. Wait, what's happening here? Uh-oh. The core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with 1 neutron instead of the usual 2. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's Central Anatolian Plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time. And as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the Central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding Central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the Central Anatolian Plateau has risen for around a half-mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow! Brighter green plants might give us a warning when a volcano is stirring. Turns out, unlike earthquakes, which are super unpredictable, volcanoes can sometimes show early signs. Plants growing around volcanoes look healthier when volcanic activity ramps up because they thrive on increased carbon dioxide levels, a gas that volcanoes emit during eruptions and through underground magma. They also turn browner when the volcanic activity peaks, likely due to harmful gases and heat harming the vegetation. Scientists use satellites to figure this all out. They analyzed satellite data spanning from 1984 to 2022. Future changes might be tracked through satellite imagery as well. Now, this isn't easy to measure directly, especially when volcanoes are tucked away in hard-to-reach, lush areas, such as Taal Volcano in the Philippines and Mount Etna in Italy. This way, plants could give us a heads up about volcanic eruptions years before they happen. With this new, weird method, we could save nearby communities by enhancing safety measures, minimizing property damage, and improving evacuation plans. Volcanoes and plants are often tied in mysterious ways. For example, volcanic eruptions in Krakatoa, Indonesia, gave a surprising boost to saguaro cacti in Arizona's Sonora Desert, even though they're thousands of miles away. When the infamous Krakatoa volcano erupted in the 19th century, it sent shockwaves around the world and suddenly helped nurture a generation of saguaros. These incredible cacti can be up to 40 feet tall as adults, but they start life as tiny seedlings that struggle to survive in the desert's harsh conditions. However, thanks to the cooler and wetter conditions caused by volcanic eruptions like Krakatoa, they can get unbelievable growth spurts. Chillier summers and milder winters that follow such eruptions create perfect conditions for young saguaros, which usually don't make it due to extreme heat and cold. But volcanoes not only influence plants, they're also Earth's jewelry makers. Deep beneath the surface, in the fiery heart of a volcano, conditions are just right to form dazzling gems. When volcanoes erupt, they can bring these treasures up to the surface. One of the most famous gems created by volcanic activity is the diamond. They're usually found in a rare type of volcanic rock called kimberlite, which forms deep within the Earth under extreme pressure and temperature. Millions of years ago, kimberlite eruptions, small but powerful volcanic events, hauled diamonds from deep within the Earth. This created sources for many of today's diamond mines. Now, these eruptions didn't happen just anywhere, but originated from the stable hearts of continents, known as cratons. They were bursting forth from as deep as 75 miles underground. Fueled by a mix of carbon dioxide and water, they were like natural rockets, blasting through the earth to form carrot-shaped channels filled with diamond-laden rocks. Recently, scientists have delved into why these eruptions happen. They suggested that the breakup of ancient supercontinents like Pangaea disrupted the mantle's flow underneath, triggering these spectacular kimberlite eruptions. When a volcano that hosts kimberlite erupts, it can propel these precious stones toward the surface, where we eventually find them. There are other gems that can be found in solidified lava, like peridot, a bright green stone that forms in the molten rock of the upper mantle and is brought to the surface by volcanic activity. There's also obsidian, a shiny glass-like rock that forms when lava cools rapidly. And then there are some insane rocks, like the ones that can hold water in them, even in lava. The deeper we dive in volcanoes, the rarer are the gems we can find. If we dive into the thick layer known as the mantle, we might find olivine, a resilient, pretty green mineral that makes up about half of this layer. It loves high temperatures and happily forms in lava, eventually crystallizing into the igneous rocks we find scattered across the Earth's surface thanks to volcanic eruptions. As olivine cools, it starts to crystallize. Sometimes these crystals are tiny, but other times they grow large and can be polished into beautiful gemstones used in jewelry or industrial processes like metal casing. But as we venture deeper, about 250 miles down, olivine undergoes a fascinating transformation. Here we encountered the layer that's called the transition zone. In the transition zone, the pressure is intense and the heat is on the rise. In this place, olivine morphs into exotic materials like wadleysite and ringwoodite. They show a lovely blue-green hue and a glossy sheen. While they're too rare and small for jewelry, they have a unique ability to hold water within their structures, not as droplets, but as hydrogen and oxygen components, making up to 3% of their volume. Later, it turned out that the transition zone is not just a pressure cooker for minerals, it's a giant sponge, holding a vast underground water reservoir. This was a groundbreaking discovery. You get the pun? This hidden water doesn't form an ocean as we know it, but suggests vast amounts of water are stored deep within the Earth. Volcanoes can help us learn more about life not only on our planet, but on others as well. In the fiery heart of Costa Rica's Poas volcano lies Laguna Caliente. This hydrothermal crater lake is among the most brutal environments on Earth. We've got a whole bunch here: scalding temperatures, toxic minerals, and water so acidic it can corrode metal. But despite all that, there's a few tough microorganisms that manage to thrive in these conditions. And this remarkable survival has caught the attention of scientists because it might just hold clues about life on Mars. Scientists are studying these extreme microbes. Turns out they've developed a myriad of genetic adaptations to withstand their harsh surroundings. They have genes that help them process everything, from sulfur and iron to carbon and bioplastic granules. All these things could be crucial in environments as challenging as Mars. NASA's Perseverance rover is currently exploring the crater rim of Jezero crater on Mars. Previously, we looked for Martian life signs in places like old stream beds and river deltas. However, the discovery of Laguna Caliente suggests that we should probably look for life in the remnants of ancient Martian hot springs as well. These spots might have once had the right cocktail of heat, water, and energy sources that are thought to be essential for kickstarting biology. Volcanoes can help planets in many ways, but they can also destroy life. Scientists believe that volcanic activity was one of the main reasons for at least 3 of Earth's 5 mass extinctions. Take the mass extinction of dinosaurs. We're used to blaming it on the Chicxulub meteorite, but there's a chance it could have been caused by volcanoes. The consequences of the eruptions can be horrifying. Mount Tambora, located on the Indonesian island of Sumbawa, erupted in 1815 and was the most powerful eruption ever recorded in history. This massive eruption was so strong it ejected between 8 to 11 cubic miles of material. It was so loud that the sounds of the eruption were heard as far away as Sumatra, over 1,600 miles distant. Before its catastrophic eruption, Tambora had been dormant for centuries, and its magma chamber slowly cooled and crystallized. This process built up immense pressure inside the volcano. It was eventually released in a series of terrifying events starting on April 5, 1815. The climax came on April 10th, when massive plumes of ash and pumice were thrown into the atmosphere. The aftermath of the eruption was dire. Tsunamis devastated the surrounding area. It's estimated that around 4,600 people passed away immediately from the eruption itself, with ash fallouts affecting air quality and water sources across the region. This event came down in history as the year without a summer. This was due to the vast amount of sulfur dioxide Tambora ejected into the stratosphere. It created a veil of aerosols that reflected sunlight and significantly lowered global temperatures. A similar thing happened to our planet 66 million years ago, during the dinosaur extinction. The sky turned black for months. I mean, I wasn't there, but that's what they say. This is not some hypothetical situation or fairy tale. The Vesuvius supervolcano that erased the city of Pompeii may wake up again and destroy many other towns built near the mountain. And to understand what consequences humanity would face if it wakens this time, it's smart to know what the eruption did 2,000 years ago with the ancient city. So, Pompeii was a thriving city in the Roman Empire, located just 5 miles from Vesuvius on the west coast of Italy. It was a resort where the noblest and richest people rested. They walked along cozy streets, lived in beautiful villas, and had fun beside fountains. The soil in this region was fertile since the ground around the volcano had a lot of useful elements. Olives and grapes from Pompeii were sold throughout the empire. About 12,000 people lived in Pompeii by the time of the eruption. It seems not so much compared to modern standards, but it was considered a big city in those days. The catastrophe began unexpectedly in 79 CE. At first, everyone felt the ground tremble. Birds flew away from the volcano as far as possible. There was tension in the air because of the impending catastrophe. The volcano started to release thick smoke, soot, and ash. There was so much of it that soon it obscured the sky over the city with a heavy gray cloud. Vesuvius spat out gases, rocks, and dirt. Hot ash polluted the air and made it difficult for people to breathe. Locals couldn't see inside this gray haze. And then it started raining heavily. The water mixed with ash and soot and fell on Pompeii. Roofs of houses broke under the heavy weight of mud. Streets, fountains, alleys, and squares were hidden under millions of tons of soot. The next day, the destruction continued with renewed force. There was an explosion of hot gas and crushed rock at the top of the mountain. A devastating blast wave at a speed of 100 miles per hour dispersed in all directions and vaporized all the trees in its path. When the wave reached Pompeii, it turned the city into ruins. On the second day, the eruption stopped. By this time, the great town had been lying under a thick blanket of ash. By the way, this type of eruption is called an explosive one. But when lava flows out of a volcano and causes a fire, this is a quiet eruption. The last time Vesuvius erupted was in 1944, but even today, it's still one of the most dangerous volcanoes in the world. But nobody's afraid of it. 3 million people live around the mountain, about 20 miles from the crater. If the volcano wakes up, it could be one of the most enormous cataclysms in the modern world. Pompeii was destroyed almost 2,000 years ago. Since then, science and technology have advanced a lot. We're planning to colonize Mars someday. We've created a metaverse, but so far, we're still powerless before the forces of nature. An erupting supervolcano can destroy nature around it and cause technogenic catastrophes in big cities. The phone lines would be overloaded and people wouldn't be able to call their loved ones or the rescue services. There would be big traffic jams on the roads. Panic would spread throughout the streets. Fires would start because of falling hot soot. All flights would be canceled, and locals would have to hide in airports, supermarkets, and the subway. A large gray cloud would obscure the sun and make the air hot. The only thing that can help us in such a situation is a preliminary warning about the upcoming eruption and good preparation. So if the disaster starts while walking on the streets, you should take shelter in a car or building. It's better to buy a dust mask in advance that allows you to breathe freely. If there's no mask, cover your nose and mouth with any cloth. If you stay at home, close all doors and windows so volcanic ash can't get into your apartment or home. These incandescent particles can easily set fire to a carpet or curtains. Put wet towels under the door sills. If you need to go outside for some reason, wear a suit covering your body completely. Don't forget about the protection for your eyes. Put on special glasses that have a dust-proof function, and remember about the mask. If you have a house, you need to disconnect the downpipes from the gutters to avoid clogging the drains. If your house has a rainwater collection system, you need to disconnect the pipes from the tank. Rain with ashes is a hot, dense mess that can easily break the water supply system. Fill the tub and sink to have water for washing and cleaning in case the central water supply is turned off. Set the lowest temperature on the fridge and freezer. Your food will be stored much longer if electricity is shut down in the city. Go to a room without windows above ground level and wait for a message from authorities on the radio or TV. Keep the receiver close to you so you don't miss anything important. The device must have a full charge, a strong body, and a powerful antenna. Here's an excellent option for survival in the ash apocalypse. The eruption is intensifying, and you hear on the radio about the evacuation. At this point, you need to calm down and follow the instructions from rescuers. Collect a bag at home with food, water, and medical supplies. Your emergency kit should include flares, maps, a first aid kit, sleeping bags, flashlights, a fire extinguisher, a portable phone charger, car tools, and a few charged batteries. You should always have a filled gasoline canister if you live near an active volcano. Going to the gas station is not a good idea during the evacuation. You can get into a long traffic jam and spend too much time in it. If you don't have a car, ask your friends for help or pay someone for a ride. It's possible the city administration would organize buses for evacuation. You would find out about it through the radio. In any case, before leaving the house, don't forget to turn off the gas and electrical devices and shut off the valve with the water supply to prevent your home from a gas leak or flooding.
Government officials.
So, you're driving a car. The authorities must announce the plans for evacuation. Don't go off the route because some roads can be blocked. Perhaps they will say the eruption is over and you can return home. Maybe the eruption will be so strong that it will destroy the city. Anyway, if you're prepared, you'll have fewer things to worry about. Modern seismic sensors monitor the fluctuations of tectonic plates and the volcano's activity, so the eruption won't be a surprise. Pompeii is far from the only city destroyed by the eruption. In 1785, a similar disaster occurred in the Japanese town of Aogoshima. It was located right in the crater of an active volcano, and one day it woke up. It was sunny weather, and no one suspected a disaster was coming. At some point, the birds rose in the air and flew away. Then the ground began to shake. A heavy, low sound came from the depths of the island, and thick streams of smoke and ash erupted from the volcano. The volcano threw dirt and big red-hot stones into the sky. It looked like a meteor shower. People evacuated, and the mountain continued to erupt for several weeks. When the ashes settled, the volcano fell asleep again, and people began to return to their city. Despite the risk of a new eruption, they continue to live and work there today. Since then, more than 200 years have passed, and the volcano never woke up. Meteorological and seismological services monitor the situation and seismic activity. After all the horrors and devastation that a volcanic eruption leads to, harmony in nature eventually comes. Decades and centuries later, volcanic ash, rich in helpful food elements, settles on the soil and makes it fertile. Then life will rise from the ashes like a phoenix.
Fraser Island sits off the coast of sunny Queensland, Australia. But don't fall for its beauty. It's home to the most dangerous beach in the world. There's nowhere on the island to seek medical attention. If you do run into danger, you're on your own. Dingo attacks are super common here. If you don't know what a dingo is, it looks like an adorable dog. But beware, this wild breed is extremely dangerous. And the dingo's gnashing teeth aren't the only thing to be scared of. The seas around the island are swimming with great white sharks. There's jellyfish in the water too. Fraser Island is home to some of the world's most dangerous kinds, including the Portuguese bluebottle. One sting from its venomous tentacle is enough to take down an adult human. Even if you manage to avoid the creatures on the island, the sea itself is perilous. The waters are incredibly rough and have powerful riptides. These are strong currents that will pull you away from the shore. And remember, there are no lifeguards to come to your rescue if you get in trouble. Even the sand is dangerous. Car rollovers in the thick dunes happen all the time. It's definitely best to swap your car for a dune buggy. Travelers also often drive down the dunes straight into the lakes below. But the lakes are incredibly shallow, which is not very safe. Fraser Island is also known for its beautiful lookout points, but you'll need to watch your step. You might feel on top of the world, but stay well away from the edges as jagged rocks and crashing waves line the shore below. There's an island in Brazil known as Snake Island, which is equally dangerous. I wonder what the hazard could be here. It's home to thousands of golden lancehead vipers, which are one of the most venomous snakes on the planet. They grow to over 20 inches long, and their fast-acting venom melts the flesh from around their bites. There are around 4,000 snakes on the tiny 106-acre isle. Snake Island has become so dangerous that the Brazilian authorities had to ban everyone from going there. For years, the only human inhabitants to brave the island were a lighthouse keeper and his family. But local legend says that one night a group of snakes crawled in through a window to attack, and the family was never seen again. Known as the gas mask town, the island of Miyakijima is not one to visit in a hurry. It's home to a fiery, active volcano that has erupted several times over the past few years. There were several massive eruptions leading to the spread of a highly poisonous gas across the island. Residents are now required to carry gas masks at all times, and a terrifying alarm blares across the island whenever the poison levels get too high. The island is also in the middle of the Devil's Sea. Ships mysteriously vanish in the area, and experts have no idea why. The North Sentinel Island is home to a remote and unwelcoming tribe. They lived alone on the island without any modern technology or contact with the outside world for over 60,000 years. And that's just the way they like it. They've been known to fire arrows at anyone who attempts to enter the island. There are many stories of people visiting the island, and they are never seen again. It's not ghoulish ghosts or slithering snakes that you have to worry about on the Caribbean island of Saba. It's hurricanes. The tiny island has been hit by more severe hurricanes than anywhere in the world over the last 150 years. There have even been 7 tropical cyclones, which is an intense circular storm. The winds in these storms can reach 254 kilometers an hour. Try standing up in that. You'll also struggle to find a pilot who'll even land on the island. It's incredibly dangerous not because of the winds, but because it's home to the shortest runway in the world. It's only 440 yards long. 2 huge rocky ridges surround the runway, so there's no room for mistakes. The Kilauea beaches of Hawaii used to be one of the most dangerous in the world. The Kilauea volcano has been almost consistently erupting for the past 35 years, spewing red-hot lava into the surrounding waters. The water temperatures have even passed boiling point as a result of the lava. Happily, it's no longer active. While the island of Bikini Atoll might sound like the perfect summer vacation destination, it's most certainly not. The problem is that this place has dangerously high radiation levels, and the locals had to leave it. Although the island was declared safe in the 90s, its original inhabitants have refused to return. The lack of fishing in the area has also led to a massive increase in sharks who swim the waters in search of their next meal. Strangely, the corals and reefs are thriving. From the distance, Ramree Island looks idyllic. White sand, swaying palms. But beware. They say thousands of hungry saltwater crocodiles used to lurk there, ready to strike at any time. The exact number of those animals was unknown, and some scientists claim that there are quite a few of them right now. I'd stay well clear of the island though. I don't really feel like becoming crocodile food. Skeleton Coast in Namibia is appropriately named as the harsh landscape and lack of water make life almost impossible. Whale carcasses, turtle shells, and elephant rib cages litter the shore. If that isn't bad enough, lions and hyenas patrol the beach in search of their next meal. The surrounding waters are just as dangerous, as they are home to 11 different species of shark. Many sailors have become lost on this coast and have never been seen again. Cape Tribulation in Australia also lives up to its name as it is packed, full of dangers. Swimmers have to wear special stinger suits because the water is teeming with stinging jellyfish. Saltwater crocodiles also hide in the water, but they don't make a suit to keep you safe from those. It's not just the jellyfish that sting. The area is covered in stinging trees. The trees have jagged leaves that give the crocs' teeth a run for their money. On land, there's angry cassowary birds. There are flightless birds that are the same size as an ostrich. They have sharp talons that can easily slice through skin. The Utterkleiv beach in Norway is one of the best places to see the northern lights, but you'll be lucky if you survive more than one night there. The seas surrounding the island can reach 46 degrees Fahrenheit, and that's just in the summer. It probably feels like swimming in ice cream. For years, Gansby Beach has remained a habitat for the most dangerous creatures on the planet. Sharks are particular fans of its waters, and the coastal stretch is known as the Great White Shark Capital. The sharks are attracted to the 60,000 sea lions that flock to the beach every year. Not just shark food, wild sea lions can be unpredictable and aggressive towards humans. Comoro Islands are the worst vacation destination for those who don't really like mosquitoes. The place is swarming with the little guys. Locals say all the water on the island must be contaminated because of them. So they like to sterilize water before drinking, making ice, and even brushing their teeth. If you're really into coconuts, there's one place you should probably go to grab some. I'm talking Danger Island. Yep, it's the real name of one of the islands in the Chagos archipelago. It shouldn't scare you off though. The major problem it has is parking. I mean, safe anchorage for those who come there. Finally, while it may sound dreamy, you're probably going to want to avoid the beaches of the Amazon. Sharp-toothed red-bellied piranhas, anacondas, and electric eels are just some of the beach's regular residents. It has one of the widest varieties of animal species on the planet, including the Amazonian giant centipede, which has a poisonous bite. It's not just the animals of the Amazon that you have to watch out for. Strychnos and curare are the two Amazonian plants that are super poisonous.
The ground shakes beneath you. The pictures rattle on the walls. You hear a rumble off in the distance. Then, boom, a deafening explosion. The shockwave blasts through the windows and sets off car alarms. You duck under the dining table for cover, but then you remember you live not far from a supervolcano in the middle of a tropical jungle. So, staying in one place isn't a good idea. The shaking finally halts. You take this chance to peek outside and see a giant cloud of smoke covering the sky. It's lunchtime, but you wouldn't know it. The sun is completely veiled and darkness falls. The power's out in the whole city. In this darkness, you see red molten lava shooting from the sky and spilling on the rim. You run outside along with dozens of your neighbors. Your priority right now, find safe shelter and fast. You think about taking the car, but with everyone running on the road, that's a no-go. So you run on foot where the crowd is going. Supervolcanoes are in a league of their own when it comes to natural disasters. Surprisingly, it's not all about size or height. A volcano is dubbed super if it erupts more than 240 cubic miles of magma. That's more than enough to overfill Lake Erie. It must also have a history of erupting and a magnitude of 8 on the Volcanic Explosivity Index. The largest active volcano on Earth is Hawaii's Mauna Loa. It's so big, it would cover the entire state of Rhode Island plus some. And next time you see a commercial plane flying high in the sky, remember that 30,000 some foot altitude is about as tall as Mauna Loa is from base to summit. It's technically taller than Everest when you measure it like that, yet it's not considered a supervolcano. So you're running along the dark road not knowing and barely seeing where to go. Then, all of a sudden, a massive flaming boulder smashes through the bridge in front of you. You and everyone else are now stranded on the side of the volcano as it's getting more chaotic each second. Most of the crowd disperses, finding their own ways to safety. You remember there's a way to the other side not many people know about, but you'll have to cross a raging river through the dense jungle. You calm what's left of the crowd, and everyone follows you to your secret getaway. You finally get out of the city limits and head into the jungle. With the sky already dark, the tall trees and thick leaves make it almost pitch black. Everyone gets out their phone flashlights to navigate through the dark path. You all need to stick together and make sure nobody gets lost. Suddenly, fiery rocks strike the trees not far from you. Everyone jolts and tries to rush ahead, but nowhere is safe when it's raining scalding fire all around. You and your group have to pick up the pace or else. Imagine a typical avalanche or mudslide, very dangerous situations on their own. Now, imagine an avalanche of lava rocks and lava sliding down a mountain instead of mud. That's what's making its way towards you right now. More and more people catch up with your group and bring news that the entire neighborhood is submerged in lava. It's traveling quicker than you thought. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can move slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous problem. If you didn't have protection, the gases spewing from the eruption would fill your lungs, and those spread faster and further than the lava flow. Your eyes and throat would be itchy. You'd get a headache, dizziness, increased heart rate, difficulty breathing. The worst would be passing out from the lack of oxygen. Luckily, everyone managed to grab their gas masks before leaving their homes. You're now entering the treacherous terrain of the jungle and the danger zone. Everyone's phone batteries are giving out one by one, so your vision is even more limited. The terrain is tougher, and you can't hear any sounds from the river. At this point, you're not even sure if you're going the right way. But your instincts tell you the deeper you go, the safer you'll be. The path is muddy, and the vines are hindering everyone's movements. That's when you hear something big running through the jungle. It's coming up on you fast. You can't see a thing until it's right up on you. A bear! And there goes a rhino. Wild cats, domestic cats, dogs, different creatures of all sizes and species. They all come running through the jungle right past you. You and your fellow humans aren't the only ones fleeing from the eruption. The rumbling is still going on. Before you know it, a shower of fire rocks strikes right behind you and ignites parts of the jungle. There's no going back. Everyone picks up and runs for it. You hear thunder in the distance. A flash of lightning lights up the dark sky. You think, finally, some rain to wash away this fiery nightmare. But that's not a regular storm brewing. These giant smoke clouds can mimic a thunderstorm under similar conditions. Your luck finally pays off. You hear the river straight ahead. You reach the bank and have to hop on some stones to get to the other side. You almost slip when someone from the group catches you just in time. Whew, that was too close. Not far down the river is a large waterfall leading straight to a shallow lake with sharp rocks at the bottom. The ash from the lava falls like snow, covering most of the trees and landing on the river. Ash is one of the most dangerous things about volcanic eruptions. You're soaked to the bone, but it's a lot better than ash and smoke. And then the rest of the group follow. The next thing you know, the river starts steaming as lava meets the bank and runs into the water. You try your best to speed things up. The lava can heat this water up to dangerous levels, and there are still people slowly crossing the river on the slippery rocks. Luckily, you manage to get everyone across. Well, almost everyone. You turn around and see someone's leg got caught between two rocks. The lava continues to pour into the river. You can feel the heat of the steam. You rush back to this person and try to pull them out. Their leg won't budge. Someone else from the group comes to help, and you're finally able to pull them out in the nick of time. You and everyone else, now exhausted from your trek, keep going as far as possible. That's when you see the main road that connects you to the broken bridge. There are others on the road that got out safely, and even some cars filling up with survivors and heading fast out of the area. The volcano is still spewing lava, and the entire city is flooded with it. What was once your town now looks like a giant burning lake. Planes and helicopters can't fly because of the smoke and ash, so don't count on an air rescue. You're still at risk even though you're on safer ground, so it's still too early to celebrate. Everyone continues to move away from the city. The further, the better. The ground continues to shake, but this time it's even more intense than before. Supervolcanoes are powerful enough to cause many earthquakes, but it's a good thing you're out in the open, far from the buildings and debris in the city. Now, back to reality. Rest assured that a volcanic eruption of this intensity won't happen for a very long time, as in millions of years. Besides, thanks to warning systems and humanity's preparation for such an event, it's extremely rare for even a regular volcano to do as much damage as it could. So, don't scratch Yellowstone off your travel list just yet. So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud ponds, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce super eruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 super eruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by 2 previously unknown super eruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down, or just maybe one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface. And the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea. But sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be. And the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well, there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight.
One of the few places you haven't traveled to yet is a volcano. It's an opening in the Earth's crust through which hot gases, molten rock, and other stuff get to the surface of the planet. But which one should you choose? There are different kinds of them. For example, shield volcanoes are built almost entirely of solidified lava flows, or lava domes formed by small masses of lava that are too thick to travel great distances. You can also pick a cinder cone. It's the simplest kind of volcano out there. It's built from blobs of almost solid lava that erupts from a single vent. This lava is ejected into the air with great force. Then it breaks into tiny fragments that become solid and fall back as cinders. With time, they form an oval or circular cone around the vent. Such cones rarely rise more than 1,000 feet. But what if you choose something even more impressive? How about traveling down a stratovolcano? Huge, steep-sided, and powerful. Once you've made your choice, you also decide to opt for an active volcano that is erupting at this very moment. What you're observing now is called a glowing avalanche. The volcano has just erupted a huge portion of lava, which has created a pyroclastic flow. Its temperature can reach an insane 1,300 degrees Fahrenheit. You see how this flow gets formed from rock fragments and surges down the flank of the volcano at a speed of several hundred miles per hour. Ash is raining down on Earth like grayish, powdery snow. Volcanic ash consists of tiny particles of pulverized rock, volcanic glass, and minerals. When the ash gets mixed with the water from mountain streams and rivers, raging mud flows appear. Despite how scary it all looks, you get closer. Good thing you're wearing a protective suit that can withstand any temperature. The nearer you get, the more fumaroles you spot. These are holes and cracks at the base of the volcano and in its slopes. They emit huge clouds of steam and volcanic gases, carbon dioxide and sulfur dioxide. Some of the cracks are so large, you can probably squeeze through and sneak a peek inside the volcano. But you have a different destination, the crater. On your way there, you spot a strange conical structure on the side of the volcano. It looks like a horn growing on the main cone. It must be a secondary cone, also known as a parasitic cone. Such cones form around secondary vents that reach the surface of large volcanoes. In this case, an eruption can occur not only through the main vent at the top of the volcano, but also through these additional vents. In any case, that's not where you're heading. Soon, you reach the crater. It's a massive circular basin. When you go to its edge and look inside, you see it's also very deep. The lava vent, which is where you need to go, is at the bottom of the crater. But even before jumping into the vent, you spot some strange tubes hiding under the lava flow. Those are lava tubes, natural passages through which fresh liquid lava travels beneath the surface of the lava flow. You decide to make a detour and follow one of the tunnels. It's the main lava tube. You also spot several smaller tubes. They supply lava to one or more lava flows. If the volcano wasn't erupting at the moment, the lava would drain downslope from this tube system. The passages would have lava marks on the walls, a flat floor, and lava stalactites hanging from the ceiling. But even now, there's some empty space above the flowing lava. That's because it has eroded downward, making the tube deeper. But right now, you need to get back. You take the next turn and get back to the crater. You wait till the volcano spews another portion of boiling lava and dive into the volcano's throat. It's the entrance of the volcano. Lava and volcanic ash get ejected from here. The volcano's throat is wide, and you easily travel deeper down. The lava around you glows bright red and orange. That's because when it first bursts to the surface, its temperature can reach 2200 degrees Fahrenheit. That's hot enough to melt iron. You move down the volcano's main vent. It's a weak point in our planet's crust. There, scorching hot magma manages to escape from its chamber and reach the surface. While going deeper and deeper into the vent, you notice sills. Sometimes, lava intrudes between the crack in the crust, pools there, and crystallizes. This creates deposits of ash and solidified lava. That's what sills are. Pretty soon, you reach a magma chamber. It's a large pool of molten rock. The one you're in at the moment is quite shallow. That's because it's not the main one. After traveling several more miles down through the vent, you get to another huge magma chamber. It supplies the small one beneath the base of the volcano. The main magma chamber lies in Earth's crust, which stretches from 3 to 44 miles deep. The molten rock there remains under extreme pressure, and the temperatures inside are incredibly high. With time, the rock surrounding the magma chamber starts to break and fracture. This creates outlets for the magma, and since it's made of a much less dense material than the surrounding rock, the magma begins to seep through the cracks to the surface. From the main chamber, it rises to the upper one. Then it makes its way to the surface in a powerful eruption. You explore the magma chamber and then decide to go even deeper than that, to the place from where all that molten rock gets into the magma chamber. You're moving through the crust. The volcano is located on land. That's why your trip takes longer than it would if you were traveling through the oceanic crust. It's only 3 to 6 miles wide. But the continental crust is much thicker. It can be 28 miles thick in some places. As you're going through the crust, you can't but notice its light color. That's because it consists mostly of granite. If you were going through the oceanic crust, the material surrounding you would be dark or nearly black because it has a different composition. The deeper you go, the hotter it becomes. Sure, the temperature here isn't as high as in the magma chamber, but still, at the boundary with the mantle, your thermometer shows 750 degrees Fahrenheit. At a depth of about 20 miles, you reach the boundary between the crust and the Earth's upper mantle. There, the pressure reaches a mind-boggling 10,000 atmospheres. That's where magma comes from. You could finish your journey and get back to the surface, but your curiosity gets the better of you. You decide to go deeper, all the way to the center of the Earth. The next layer on your way is the mantle. It makes up 2/3 of the Earth's mass and 84% of our planet's volume. It's 1,800 miles thick. The rock closer to the inner part of the mantle is semi-solid, like caramel candy. The upper part of the mantle, as well as the crust, is broken into massive pieces. They look like a colossal jigsaw puzzle. Those are tectonic plates. They drift at a speed of 1 to 2 inches per year. You're moving through the upper mantle and feel the temperatures rising up to 1,600 degrees Fahrenheit. Near the boundary with the core, the temperature is already as high as 7,000 degrees Fahrenheit. The pressure in the lower mantle reaches 240,000 atmospheres. You'd feel the same pressure if 3,300 elephants made a tower on your head. At a depth of about 1,800 miles, you see the boundary between the mantle and the outer core. The insides of the planet around you are heated up to 9,000 degrees Fahrenheit. Such temperature is high enough to keep the outer core liquid. The pressure there is almost 2 million atmospheres, but it's not enough to make the iron that the core is made of solid again. The outer core is 1,500 miles thick. It churns in massive turbulent currents and generates a magnetic field. In the outer core, Earth's magnetic field is 50 times more powerful than at the surface. You are now more than 3,000 miles underground, and you've reached the inner core. It's a solid metal sphere, around 1,500 miles across. The inner core is immensely dense and spins faster than the rest of the planet. The temperature there is as high as on the surface of the sun, 9,800 degrees Fahrenheit. and the pressure inside the inner core is 3 million times greater than on the surface. It took about 500 million years for the inner core to form, which means it's younger than some parts of the crust.
It happened in Iceland on Friday, March 19, 2021 at 8:45 p.m. About 20 miles southwest of the capital. Molten rock suddenly burst through the surface from below. Bright lava fountains then lit up the night sky. A volcano in this valley finally woke up after almost 800 years of sleeping soundly. We divide volcanoes into 3 categories: active, dormant, or extinct. Around 1,900 of them around the globe are considered active. That means they've erupted in the recent past and will likely do it again in the possible near future. Dormant volcanoes haven't popped off for a long time, but they still may in the future. You could say they're sort of sleeping. As for extinct ones, those guys haven't done anything in more than 1 million years. The eruption in Iceland wasn't super explosive, and this all happened 6 miles from the nearest town, so everyone was perfectly safe. Many even came to see it up close, while other brave visitors tried to fry eggs and bacon on the lava. Just be careful not to burn your breakfast black. Lava can be over 2,000 degrees Fahrenheit. It burns everything in its path. Yet it also produces some of the most fertile land for agriculture. This eruption gave a relatively small amount of lava at first, but it's been spreading across the valley in different directions, forming a sort of shield that's constantly growing. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can ooze slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous thing about volcanoes. That would be the toxic gases spewing from the eruption. And those spread faster and further than the lava flow. Luckily, in Iceland's case, the wind has been blowing these gases away from residential areas. Scientists weren't surprised this volcano erupted. They knew it was coming. Increasingly stronger earthquakes had been shaking this area for the past 15 months. There were 50,000 earthquakes within just the 3 weeks leading up to the eruption. That's 100 per hour. The volcano has been active since March, and geologists say this could last for weeks, months, years, or even decades of constant eruptions in the area. Mount Shasta is in the top 5 most dangerous volcanoes in the U.S., so geologists are keeping a close eye on it. The last eruption was in 1250. I wasn't around then, but this volcano erupts every 600 to 800 years. Which means tick-tock, we're due any day now. About an hour from Portland, Oregon, there's an active volcano that last erupted in the 19th century. Next time it goes off, scientists think it'll produce larger amounts of ash and dust. This could cause an electrical blackout and make water unsafe to drink in the area. But the experts pay close attention to Mount Hood. They'll be able to give plenty of warning so people can react in time. Kilauea is one of the most active volcanoes in the world. It's been erupting almost constantly since 1983, making it also one of the longest eruptions known on Earth. It's the youngest land volcano in Hawaii. Volcanoes can take thousands of years to form, but others can pop up practically overnight. A volcano in Mexico just erupted in an open field in 1943. It started growing from there. Within a year, it was almost 1,500 feet tall. When the eruptions finally stopped 9 years later, the mount had reached a height of over 9,200 feet. Mount Fuji is an iconic symbol of Japan. The last time it erupted was in 1707, and it sent a shower of burning rocks as far as 60 miles away. If a similar eruption happened today, Tokyo would be within that vicinity. Mount Fuji is right on the Ring of Fire, that horseshoe-shaped region in the Pacific Ocean full of active volcanoes and earthquakes. From one end to the other, it's almost 25,000 miles long. It could wrap all the way around the Earth's equator. In January 2020, Taal volcano in the Philippines started spewing lava, sending huge plumes of ash half a mile up into the sky. The eruption even triggered a rare phenomenon, a dirty thunderstorm. That's when the smoke cloud above a volcano produces its own lightning. The chance of volcanic tsunamis was also high. Those are usually caused by tectonic movements that occur because of volcanic activity. Taal has erupted more than 30 times in the last 450 years. This volcano in Ecuador last erupted in 2016. Scientists think it might be showing some early warning signs of magma on the move. This is an active stratovolcano, a specific cone-shaped type with steep sides. They form from sticky lava that doesn't flow that easily. That lava goes around the vent, cooling and piling on itself to form these steep walls. These types are more likely to produce explosive eruptions like the ones we see in movies. Ruapehu is the oldest national park in New Zealand, a volcanic wonderland where you can closely see all those steaming craters, magnificent lakes, and unusual rock formations. It last erupted in 2007 and has had 10 eruptions since the mid-19th century. But eruptions, lava flows, and toxic gases aren't the only danger coming from volcanoes. There's also a thing called lahar, a kind of volcanic mud flow of debris. In between eruptions, snow melts and a lake forms in the caldera. If the last eruption brought mud, ash, and rocks in the lake, it becomes dangerously full. In that case, only a temporary dam holds it back. Indonesia has the biggest number of active volcanoes in the world, including one called Anak Krakatoa. It means child of Krakatoa, and its famous parent isn't far away. A huge tsunami in 2018 partially woke Junior, a scary thought since Senior had one of the most powerful eruptions ever seen on this planet in 1883. Krakatoa's boom was the loudest sound ever heard. People over 2,000 miles away could hear the explosion. The sound wave circled the globe 7 times, and scientists say it's hard to predict this volcano's eruption patterns. Mount Yasur in Vanuatu is one of just a few volcanoes in the world where you can see a lava lake. Tourists even go there to peer over the edge and get a look at the burning, bubbling lake below. Well, except for when the volcanic activity goes to levels 3 and 4 out of 5. That means there are more intense earthquakes, volcanic tremors, or steam, gas, or ash ejections. Then this place is off limits because, duh. This volcano in the DR Congo has the most active and largest lake volcano in the world. And all that lava is unusually fluid, meaning it travels faster and further than the stuff coming out of most volcanoes. It's certainly not amongst the tallest ones, but Ethiopia's Erta Ale is unique in that it has a lava lake almost constantly, which is pretty rare. The locals call it a smoking mountain because its lava lake often causes eruptions. This volcano is near the Danakil Depression, one of the hottest places on our planet. Merupi has been erupting on a regular basis since the mid-16th century. This volcano helps scientists do crucial research on how eruptions work and how they can warn people in time. After it was dormant for a while, this volcano in central Mexico sprang back to life in 1994. Ever since then, it's been producing huge mud flows and strong explosions in unpredictable intervals. In the past, enormous eruptions coming from this giant buried entire cities in pyramids. Imagine staying in a hotel and waking up to the magnificent view of a massive volcano covered in glowing rivers of lava and clouds of ash. When it lets off heat, visitors to this area in Guatemala take a chance to roast some marshmallows there. One of the most active volcanoes on Earth is on a small island north of Sicily. Stromboli has regular explosions, together with glowing lava coming from vents inside the crater. Not too far away is Etna, Europe's most active volcano and one of the biggest continental ones in the world. By the way, Earth definitely isn't the only planet with volcanoes. The largest one in our solar system is on Mars. It would cover the entire state of Arizona, and it rises nearly 3 times higher than Mount Everest. Ooh, don't look down. Huaychan Volcano in Indonesia is not your ordinary lava-belching mountain. Instead of producing black smoke and red lava, as most volcanoes do, this eccentric guy lets out a blue flame and electric blue lava. This phenomenon occurs because the volcano contains some of the highest levels of sulfur in the world, and when the sulfuric gases interact with scorching air and get lit by the molten lava, they start to turn blue. Unfortunately, you can see this mesmerizing sight only at night, but you can smell it all day long. By the way, the world's largest acid lake is also located inside this crater. The Dead Sea has a high concentration of salt and minerals compared to other seas, even though it's technically a lake. Swimming is almost impossible, but people go there for the natural chemicals for the body. Floating on the surface is a great way to relax. This ancient body of water got its name because no macroscopic organisms can live there since it's 9.6 times saltier than oceans. Only a few bacteria and fungi can be found enjoying the salt. It's also Earth's lowest elevation on land at 1,400 feet below sea level. An underground crystal cave exists in Mexico, and it looks like some interstellar world. It's roughly 1,000 feet beneath the surface, with each spike measuring up to 35 feet in length and weighing up to 55 tons. These are some of the largest crystals in the world. Luscantire Beach is an endless strand of white sand dunes and azure water. But don't let the tropical vibes fool you. It's located in Scotland. That's why it mostly looks like this during May and June only. In December, the place gets only an average of 1 hour of sunshine per day, making it way more dramatic and monochrome. The Georgia Guidestones is a collection of giant stones in a star pattern. It has inscriptions in 8 languages, including Hindi, Chinese, and Swahili. It also has an astronomical calendar finished in 1980 and was built to last centuries. No one knows who built it or why. All the way over in sunny California is Sequoia National Park, home to the giant forest. It's been around for thousands of years. More than 8,000 of these colossal trees rule the land, including 10 of the largest living plants in the world. The General Sherman sequoia is estimated to be up to 2,700 years old and is recognized as the world's largest known living tree by volume. The famous stone heads of Easter Island have been around for hundreds of years. No one knows exactly why they were built. Some scientists think that local people believe the statues would make the soil more fertile. Soil analysis proved the heads did their job well. It's the best agricultural spot on the island. The chemical composition of the ancient hot springs in Pamukkale, Turkey, makes the water pouring over the edge look magical. They're not only good for cleansing your body, but the mind too. All the way in Saudi Arabia is a rock sliced perfectly in the middle with 2 pieces sitting parallel. What makes Al Nasla so unique is that it wasn't artificially done, but is a result of nature's work over the years. Now, this glacier may look like someone dropped tons of red paint in the middle of Antarctica, but it's actually the natural color. Blood Falls is a result of extreme salted water mixed with iron oxide, giving out this eerie vibe in the middle of nowhere. In early May 2018, New England observed one of the scariest and most dangerous phenomena ever, a super long-track tornado. The frightening natural phenomenon started not far from Charleston, New Hampshire, and traveled toward the town of Webster in Merrimack County. It took the tornado 33 minutes to cover 36 miles and become the 3rd on the list of the longest track tornadoes in New England. In the Philippines, you can swim in some of the most crystal-clear waters and discover an underwater world below you in the province of Palawan. The municipality of Coron has white sandy beaches with many small boats riding through the many amazing sceneries. Tristan da Cunha is a small volcanic archipelago in the Atlantic, with the only neighboring cities of Buenos Aires, Argentina, and Cape Town, South Africa. It takes 7 days by ship to get to this unique place. If you want to escape from the rest of the world, Staying with the 280 locals will make you feel like you're away from everything. During the first week of January 2018, unusually cold weather in the northeast United States froze the Atlantic Ocean in North Falmouth, Massachusetts. What's more, the ocean was frozen so thoroughly that people were walking on the waves. Now, that's obviously something you don't see every day. Red sand is what makes this beach unique and why tourists flock to Tianjin, China. A red-colored plant called a sueda salsa dwells in the saltwater. The whole beach is covered in red, with only the top layer of the sea visible. If there ever was a thing that said, "I defy gravity" out loud, it's the stone of Davasco in Argentina. The huge 300-ton boulder stands precariously on the edge of a cliff and rocks a little bit from side to side in the wind. People even checked it by putting glass bottles under one of its edges. They exploded with another movement of the rock. Unfortunately today, you can't see this wonder of nature as it was a century ago. In 1912, the boulder suddenly dropped from its perch, which it had occupied for literally hundreds of years. The people of the nearby town of Tandil were so sad about this event that 95 years later, in 2007, they decided to restore the stone. They made a plastic replica of the rock and put it on the same spot and even in the same position. So, even today, coming by Tandil, you can see its famous balancing boulder. More of a symbol now, of course, because it's no longer rocking and only weighs 9 tons, but instantly recognizable nonetheless. Socotra is an alien-like island off the coast of Yemen in the Indian Ocean, with one of the most unique trees ever seen. It's called the dragon tree, and it can only be found on this amazing island. In 2008, it was labeled as a World Heritage Site. If you ever see a tight burning column of air, don't panic, it's not the end of the world. The creepy combination of whirlwind sounds and scorching inferno means that you have crossed paths with a fire tornado, also known as fire twister or fire whirl. This dangerous phenomenon occurs mostly during wildfires. These fires create a big area of superhot air just above the ground. When this scorching air gets mixed with the cooler air higher up, it results in a whirlwind that churns up burning debris and flames. The most powerful firenadoes can stretch hundreds of feet into the air. The House of Mystery in Gold Hill, Oregon, amazes its visitors with gravity-defying effects. You can't stand straight there, always leaning to the side and having to hold on to something for balance. Balls roll upwards. There's also a broom that stands perfectly still wherever you put it, unlike virtually everything else in the shack. The local Native American tribes called this place the Forbidden Ground, even before the house was built there, and they avoid approaching it. The owners of the shack, though, decided to turn it into an attraction, and they succeeded. They created an atmosphere of mystery around the place, and spread the news about it in newspapers and later on the internet, and voila! A perfect anomaly is made. In fact, it's no more than a curiosity. A human-made optical illusion that tricks your eyes and other senses. Now, if you travel to the Philippines, Indonesia, or Papua New Guinea, you'll have a chance to see some of the most unusual and cheerful trees in the world. The trunk of the rainbow eucalyptus looks as if it had been painted orange, green, red, purple, yellow, brown, blue, hey, you name it. Some trees are so bright that they seem artificial. The rainbow eucalyptus regularly sheds strips of bark, which reveals a bright green layer underneath. A bit later, this green layer gradually changes its color, and since the shedding happens at a different time in different places on the trunk, the tree starts to look multicolored and very attractive. Yemen is home to the oldest skyscrapers in the world and the oldest metropolis. The ancient city of Shabam is considered to be the Manhattan of the desert, due to the collection of mud buildings popping out of the desert floor. It used to be a caravan stop during ancient times. Day 1. A small but powerful tremor is shaking the city of Naples, Italy. The news networks are reporting on the event. The experts believe that Mount Vesuvius, the stratovolcano on the Gulf of Naples, will explode soon. But when? It's erupted many times in the past. In fact, that's how it got its shape. It's made of multiple layers of hardened lava, pumice, and ash. Vesuvius last erupted in 1944, but a major blast happened there nearly 2,000 years ago. It buried the Roman towns of Pompeii and Herculaneum and decimated the surrounding areas. Today, 3 million people live less than 20 miles from the volcano, and 600,000 live in the danger zone. Large eruptions happen every few thousand years, usually after long periods of calm. And the trouble is, Vesuvius is long overdue for its next one. This time, though, the volcano is being watched by the Vesuvius Observatory. It has seismic stations, special GPS arrays, and satellite-based radar to help it measure ground movement. They also have special equipment to test the chemicals found in the gases coming from the volcano. All of this helps the experts work out whether it's about to go off. But will it? Right now, the magma is more than 6 miles from the surface. Things seemed safe yesterday, but now they're about to take a turn for the worse. Day 3. Another tremor comes in measuring 3 on the Richter scale. All the equipment that's installed near the volcano is now going off. The magma is pushing upwards. It's not at the surface yet, but Vesuvius is definitely restless. 2 more tremors follow in the afternoon. They don't feel like regular earthquakes, and geologists can see the difference in their seismographs. Volcanic quakes register about 4 to 5 less on the Richter scale. Now, the experts are sure it's just a matter of days or weeks until the volcano erupts. Some volcanoes can be restless for months or even years before they go off. But that's not how it goes with Vesuvius. Day 4. The ground starts to crack open, as if a giant creature is trapped in the Earth's crust and is trying to desperately get out for some air. Steam escapes from the little cracks in the soil. Certain areas are hotter than others. If you went there, it would feel like you walked straight into an oven, and it would be hard to breathe. Some sheep got too close to the mountain and passed out. When the farmer found them, he almost collapsed too, not from the heat, but from the gases. Carbon dioxide and hydrogen sulfide are being released into the air. The entire area around the volcano smells like rotten eggs, and many of the forest animals are now staying clear. The nearby trees have been absorbing these gases from the soil for days on end now, and they're starting to turn brown. The carbon dioxide levels in the area are skyrocketing, and all the detectors are beeping constantly. Day 6. The tremors are getting more frequent. Experts at the Vesuvius Observatory monitoring the volcano say the quakes are coming from the magma that's being pushed upwards. A few hours later, the national emergency alert goes out. Thousands of local people have around 15 days before the volcano erupts, and they need to evacuate their homes. The 600,000 people in the danger zone start to pack their suitcases and leave in cars and trucks. There's chaos everywhere. But in all that disorder, some people are standing still. They look around, trying to understand what's really going on. A few of them are taking photos of their homes. Others are streaming all the confusion on social media. But the senior citizens are just standing outside, looking at their houses one last time. They hope this is all just a false alarm. It's happened before, but who really knows? Day 7. It was a sleepless night. Plenty of the locals have already left. Some good people from other towns drive to the area to help the residents evacuate faster. There's a massive traffic jam, but everyone expected it. This is why the evacuation started early. Ferries, trains, and buses have canceled their services to help the evacuees. They're all working on a tight schedule to make sure everyone gets out safe without any delays. Some people refuse to leave, but their neighbors eventually convince them to go. It will take 7 days to evacuate everyone, and these people will spread out to other areas of the country, not just to the nearby safe regions. Day 10. More than half of the residents have now left the red zone. After the chaos, there's now silence, and it's interrupted by the eerie sounds of the tremors. Animals are being evacuated too. Many people are now trying to save as many animals from the forest as they can find. Day 16. All 25 of the towns that were at risk have now been evacuated. The red zone is empty. But the tremors are getting stronger, as the volcano is a pressure cooker ready to explode. White smoke rises from the large opening on the mountaintop and the vents on the side. The molten rock moves toward the surface, and the pressurized gases form bubbles, just like the ones you see when you boil food. Suddenly, there are some loud booms, and then an explosion. It's loud enough to be heard thousands of miles away, and the shockwave is felt throughout Italy. Volcanic rock is thrown up into the air. A thick black mushroom cloud forms and expands into the sky. The birds abandon their nests and fly away in huge flocks. The red-hot lava is now spewing out of the volcano like a fountain. As it flows downward, it obliterates everything in its path. Then there's a volcanic landslide. Part of the cone-shaped mountain falls off, and millions of tons of soil and rock break loose from the volcano's side and tumble down. The lava spreads on the slopes, and it slowly slides down into the forest and the farmlands. The plume of ash, pumice, and other kinds of rock has risen so high into the sky that people can see it from Rome. Then the tower of debris starts falling back to Earth. First comes the ash, then chunks of rock. The ash in the atmosphere is so dense that it's hard to breathe. The lava slowly spreads across the area and pulls down all the trees. All the nearby towns are shrouded in darkness and smoke. Buildings collapse, and all around there's a mixture of heated, poisonous gas and rock moving faster than a car. Other rocks and more volcanic ash fall miles away from the volcano, hitting cars and destroying roofs. The sky is completely black as the lava keeps on coming. Slowly, all the nearby towns are submerged beneath the molten rock. Some of the lava even reaches the sea. Gigantic white steam covers the shore where it falls in, and the magma turns black. Now, a weird neon blue fire appears on the slopes of Vesuvius. This is caused by burning sulfuric gases. They're escaping at high pressure from the cracks in the volcano's surface. When they come into contact with the air, they ignite. These blue flames can reach 16 feet into the air. Now, all nearby flights are canceled, and many planes have to change course to reach their destination. Ever since the national alert, no planes have been allowed to fly over the volcano. The clouds of volcanic ash can damage jet engines and other plane components. The water supply is now contaminated by streams of volcanic ash, and it smells unbelievably bad. In just a short amount of time, all that magma has made entire towns vanish. Only the roofs of taller buildings can be seen. After the big and explosive eruption, there are some smaller and quieter ones. At this stage, nobody knows if the volcano has stopped erupting yet, and absolutely no one can go anywhere near the area. 10 years later. Most parts of the red zone are now hidden under hardened but still warm lava, including the ancient site of Pompeii. Some people have started to forget about what happened. Others have begun their new lives elsewhere, and some don't even want to think about what happened to their old homes. But several of them are counting the days until they can go back. 100 years later. You're walking in what appears to be a wasteland of volcanic ash. You suddenly realize that you're standing on top of your great-grandparents' town. Everything is now submerged under a thick carpet of solidified lava. But below it all, just about everything is still intact, completely frozen in time. Hey, we landed on the moon. We sailed around the world. Romeo met Juliet. Hey, it's hard to imagine that there are creatures out there who saw it all happen. Immortal animals. Well, almost. Glass sponges are weird little creatures that sit in one place for thousands of years. From their favorite spot under the sea, they witnessed the first Europeans crossing over to the Americas. They can live up to 15,000 years. And what's even cooler is that they can control their aging process, speed it up or slow it down. They have a glass-like exoskeleton for protection. Lobsters can grow back a limb if they lose it, and they're basically immortal. They produce an unlimited number of enzymes that keeps their DNA young forever, and they just keep on growing. That means they outgrow their own shells. They have to shed their exoskeleton every now and then and upgrade to a bigger one. The largest lobster ever caught was 44 pounds off the coast of Nova Scotia. Scientists think this large lobster was around 100 years old. It was around when Edison invented the phonograph. This next creature is a mix between a jellyfish and a tree branch. Each end of the hydra has a ringed foot, and it spends its days chilling by lakes and rivers. Its tentacles grab onto tasty snacks that swim past it. So, what's the secret to its immortality? That's something everyone wants to know. The hydra has the ability to renew its stem cells. Scientists have been trying to do that for years. They can actually slow down their aging process. Now, these little sea creatures are red sea urchins. They sit on seaweed in shallow waters and are immortal. Well, we haven't been studying them long enough to know for sure. But scientists say they only grow in size, not in age. What? Well, they sort of stay like little baby urchins, but grow in size. Adult, baby urchin, okay. These little babies can reach around 100 years old, even 200. The slowest on the list? The giant tortoise. It can reach 200 years old. And one of the oldest is Jonathan. He's technically the oldest crawling land animal. He was born in 1832 and lives it up on a remote island called St. Helena. Jonathan's been through a lot. He's seen the very first American skyscraper, the Eiffel Tower. Oh yeah, he's also lived through every single World Series, starting when he was 71 years old. Now he can't see too well and he's lost his sense of smell, but he's still going strong. Back to the oceans and the Greenland shark. It's been known to be the longest living vertebrate and can live more than 400 years. Swimming around for that long in the deep, dark, cold ocean means these sharks are tough. They're able to withstand insane water pressure. Sharks are one of the only creatures today that haven't been affected too much by evolution. Many sharks have been around since the dinosaurs and haven't changed much. Scientists found out that they grow around ½ an inch per year. So, with a little bit of quick math, they can easily find out the age of these tough sharks. Imagine seeing a shark that's older than the USA. This next creature is probably the most durable, indestructible, and cutest on the list. It's called a tardigrade, but scientists nickname it water bear because I guess it looks like one. But it's not exactly bear size. It has 8 legs and hands with a strange little nose. And these bizarre microscopic creatures are indestructible. They're known to live in the most extreme places on the planet. They're fine with temperatures as high as 300 and as low as minus 330. Volcanoes, frozen desert nights, they can even handle radiation and massive amounts of pressure in the deepest parts of the ocean. They can even survive the vacuum in space. No tiny little spacesuit or anything. Yeah, that would be cute enough. So far, they've survived 10 days on the outside of a spaceship, but they could probably do longer. Tardigrades might be able to outlive humans if there's some sort of worldwide catastrophe. Microscopic organisms in charge of the planet. Wonder what that would look like. Whether it's all the volcanoes erupting at once, or another ice age, or even another pesky asteroid. Tardigrades probably wouldn't even notice. Scientists are studying them to see if they can help us with some next-level biotech. Now, just for fun, here's the mayfly. This poor little insect doesn't even make it past 24 hours on average. Females and males can make it to a whopping 2 days old. Talk about living in the moment. These little flies grow in swarms and are known to have one of the shortest lifespans of any creature. But as a species, well, they've been around for hundreds of millions of years. Jellyfish have discovered the fountain of youth, and surprise, surprise, it's been inside them all along. Not inspirational poster style, but literally, it's always been inside them. Jellyfish are able to reverse their aging process whenever they want. Imagine you're swimming along and then you think to yourself, gee, I kind of want to be 8 again. And poof, there you are. Who wouldn't want to go back to being 8? That's how jellyfish stay young and live stress-free. These brainless and boneless creatures can turn the clock back anytime they want, as long as no one bothers them. They're super chill, just floating in whatever direction the current takes them. Like, go with the flow? This creature looks like something right out of a sci-fi movie, and you could say it has sort of alien features. The giant weta outweighs a mouse and is considered one of the biggest insects out there. You find these big bugs in New Zealand. While jellyfish can reverse their aging process, some members of the Weta family can come back to life. Talk about superpowers. If they get completely frozen, they start to make special proteins that stop their organs from getting ruined. After whatever amount of time they're frozen, they can be thawed out and brought back to life, like nothing ever happened. In fact, the giant Weta has ears on its knees in its front legs. And because it can resurrect, it's also called the zombie bug. Planaria are flatworms that are unique. Apart from being practically immortal, they're the ultimate regeneration machines for lost body parts. If you take one of them and divide its body into 10 parts, you'll end up with 10 new planaria. You keep dividing them up, they'll keep multiplying, even though they're usually less than an inch long. Imagine if we could figure out how to do that. Would that be a way for us to live forever? Or would we end up with a totally crazy world with copies of everyone walking around? How about the world's fastest relay team, 4 identical Usain Bolts? Now, clams have been around for a really long time. Scientists have discovered that they can live up to 400 years old. These little shelled creatures are the ones that create those shiny little pearls everyone loves. A clam will go into action mode when a parasite gets inside. The clam tries to cover the parasite with a bunch of special chemicals, the same ones it uses to make the inside of its shell. That's when the magic starts to happen. When these chemicals harden up, they make a shiny, glossy pearl. The more chemicals, the bigger the pearl. Now, this long, slippery-looking creature lives deep in the caves of Europe. Olm can live up to be 100 years old. It spends its days hunting for little insects, snails, and crabs with its tiny front arms and wriggling snake-like body. Its skin is so pale that some locals even call it the human fish. Hey, wait a minute. The olm is almost blind, but it can still detect light. It just mostly does it through its skin. Like other blind animals, it has a supercharged sense of hearing and smell. It gets its distinct look from those little red gills around its neck. Ah, Kiev, you've been dreaming of getting here for years. Getting out your trusty camera, you start taking pictures of the cathedrals, aviation museum, and the Dnipro River, when, without warning, there's an enormous boom behind you. Turning around, you see something towering in the distance. It looks like a gigantic explosion. Uh-oh, time to leave fast. In June 2020, what the people of Kiev were looking at was an anvil cloud, a rare storm formation in the sky. Forming when strong air currents carry water vapor upwards, the air expands and spreads out as it hits the bottom of the stratosphere. It pushes the dense cloud into the cool anvil shape you see, and sometimes it even gets to be a mushroom. Anvil clouds produce some of the most dangerous lightning of all storms, one that's called a bolt out of the blue. This lightning strike seems to magically come out of the blue sky with the storm being many miles away. This type of bolt comes from the top of the anvil and can be 10 times more powerful than a typical lightning strike. People got so frightened after witnessing a giant cloud just 60 miles away, thinking something terrible must have happened. The locals had pictures of the large billow on social media before officials could explain what was going on. Authorities managed to calm everyone's fears by informing them it was nothing more than a natural phenomenon, and a beautiful one at that. Before dissipating, these clouds typically stay in one area, regardless of how strong the wind is. Touring around the northern tip of Queensland, Australia, way away from those creepy crawlies, it's time to take a break and relax at the beach. Getting comfortable, you notice a great big shadow passes over you, then another, and yet another. Looking up, this weird weather is simply stunning. The clouds are called morning glory, a very rare type of cloud that almost seems to roll across the sky, looking like a massive tube. These clouds can measure up to 600 miles long, even appearing in large groups as well. This phenomenon is the result of an updraft pushing through the cloud, creating a rolling appearance, while moist cooler air at the back causes them to sink downward. Southern India between July and September 2001. People witnessed one of the strangest weather phenomenon in recorded history. The rain was red. What many would have thought to be a typical rainstorm left them shocked. The color was bright enough to stain clothes. There were other colors too, such as green, yellow, brown, and even black. In the middle of a monsoon, red rain started to fall, and did so periodically for several weeks. Researchers have found this unusual rain is stained either by dust or algae, so don't try to catch any on your tongue. Scientists aren't entirely sure how the algae got all the way up there. This does make events like this a little unsettling. Like to take a bubble bath to relax after an exhausting day, but taking too long to fill the bathtub? Problem solved. Head to any coastline after a big storm and take a dip. Foamy tides aren't native to any one place or location. They can be formed anywhere in the world. They're most likely to happen along rocky coastlines, like the coast of San Francisco, Northern Ireland, or the Mooloolaba, Australia. Each coast has differing conditions forming the sea foams. If you scoop up seawater into a glass and look at it closely, you'll see it's full of tiny particles. Many things like plants, chemicals, and lots of salt and minerals create the perfect formula for foam. When powerful currents and wind mix it all together, we get something that resembles a cappuccino top floating on top of the water. When freezing temperatures hit orchards in Michigan, all kinds of unusual things happen, like ghost apples. No, they're not going to scare you at all. But if you plan on sneaking away one winter to find one, be warned. Everything has to be perfect for this to occur, and it's going to be freezing cold. This is actually a rare weather phenomenon caused by having the apples freeze where they are with rain coating the fruit in a thin layer of ice. The apples then thaw and leak out like applesauce, leaving just the beautiful ice shell behind. The Catatumbo River in Venezuela might be the most electric place in the world, with nearly 300 storm days per year. The lightning storms are so consistent, they're predicted for 3 months in advance. During the wet season in October, you might see 30 lightning flashes in a single minute, a truly shocking experience. With each bolt having the energy to power a single light bulb for 6 months, the impressive display could power all of Venezuela forever. At sunset, strong winds flow around the 3 surrounding mountains, forming storm clouds over the water. As the water droplets of humid air collide with ice crystals from the cold air, it produces the static charges that cause the lightning storms nearly every night. If that wasn't bad enough, some storms have lightning above them as well. Try to take a picture of this one. Jellyfish lightning sprites are electrical discharges high in Earth's atmosphere. They're associated with powerful thunderstorms, but they have nothing to do with rain. These sprites occur 30 to 50 miles up in the sky, in the mesosphere. Artificial lights at night make it a lot harder to see this faint lightning. If you spot one, it'll look tiny, but can be well over 30 miles wide. The red sprites are a type of cold plasma discharge above a thundercloud. They're the balance of the lightning charges between the storm clouds and the ground below. Don't try to find this type of donut at your favorite bakery. It won't be there. Snow donuts are one of the rarest meteorological sights to see, with perfect weather conditions needed just to create them. Found in any snow-covered mountain area, like the Rocky Mountains, the wind, temperature, snow, ice, and moisture have to all work together for us to see these phenomenal rings. A thin layer of wet snow on the ground. Under that layer, ice or powdered snow. Then, a strong enough breeze to roll the donut down a hill, just like a snowball. Once it stops rolling, it can be the size of a baseball or as large as a car tire. It all depends on how strong the wind is. A newly formed snow donut won't stay around for very long, So hurry up with that camera. Watching the sunset over the horizon, the beautiful purples and pink overhead are nothing compared to the 3 suns you see in front of you. Wow, since when did Earth get 3 suns? These phantom stars sometimes appearing beside the sun are called sundogs. Maybe they're called that because they're kind of dogging the actual sun? Sundogs often appear as colored areas of light at the same height above the horizon as the sun. They're mostly observed on a ring or halo, where ice crystals best reflect the light. There are also moon dogs that appear alongside the moon and are formed by lunar light passing through ice crystals, though these aren't seen nearly as much as their daytime partners. Taking photos in the wild, you finally found the perfect spot to take that dream shot. The crystal clear water, the pines, the mountains, and the flying saucer. Wait, a flying saucer? Oh, aliens are here! You might be thinking this if you saw a saucer-shaped cloud. I'm not even going to try to pronounce their name though. Put that on the screen, please. Wait, just kidding. It's altocumulus lenticularis. Aren't you impressed? These are really just unusual cloud formations over mountaintops. When moist air flows over a mountain, a wave is created if the temperature difference is perfect. As the air passes through the wave, evaporation occurs and a series of these clouds may form into an oval shape. Not aliens at all. Whew! The sky is falling! The sky is falling! Well, people who have experienced these clouds say they look like they're coming down from the sky. Mammatus clouds look like giant white lumpy marshmallows, but it might be hard to toast these ones. These weird fluffy clouds can extend hundreds of miles in any direction, remaining visible for short periods at the bottom of anvil or other thunderstorm clouds. The strange bubble shapes are formed from turbulence within the storm itself, creating an uneven cloud base and appearing anywhere in the world. Mammatus clouds form when moist air sinks into dry air. The air must be cooler than its surroundings, cooled with ice, or be heavy with water.
When you think of a volcano, what's the first thing that comes to mind? Streams of red, steaming hot lava pouring over the sides? Dark clouds of ash rising high into the sky? Maybe you think of a relaxing hot spring. Ah, that's nice. Well, we all imagine one thing, a cone-shaped mountain looming over the horizon. But it can be as green and lush as any other mountain. At the top, of course, there's a giant hole, like an opening that goes all the way down. Inside, there's lava and gases being pushed outside. Lava is so hot that if you were standing at the top of the volcano and looked down, your face would feel as red as the color of that liquid rock oozing out. A volcanic eruption never comes without consequences for us. And I'm not just talking about people living nearby. The impacts are usually felt on a global scale, too. Can't fly for a while because of the blanket of ash released in the air. Not to mention, it might be a bit tricky to breathe. Carbon dioxide, sulfur dioxide, and plenty of other toxic gases whose names immediately take you back to your high school chemistry class. Funny enough, most of that cloud rising out of a volcano is just water. Well, vaporized from those scalding temperatures. But before any volcano erupts, it goes through stages like an angsty teen. First, magma, that's lava before it erupts onto the surface and gets its name change, starts moving underneath the volcano. This causes earthquakes that get worse and more dangerous over time. Then, steam and different gases start spewing out of holes in the planet's crust. Our Earth resembles a tea kettle about to whistle. When the gas emissions and earthquakes get more massive, it usually means the volcano is about to blow its top. But those first stages can take years before an eruption happens. Then, the magma starts building up. With more and more pressure, it's planning to make its great escape. It's hard to notice this happening if you don't have the proper equipment. Good thing scientists do, and they've got us covered. The volcano becomes more active by the minute, Ash starts coming out and spreading in the air, creating ominous clouds that turn day to night. With the magma building up, an eruption is imminent. Then, boom! The surface gives in under the pressure below. The magma makes its exit. It's now lava, spewing out the top and flowing down the sides of the mountain. None of this sounds very appealing. So, what if it never happened? What if there were never any volcanoes at all? Would Earth still be the same? Not at all. If volcanoes never existed, there wouldn't be an atmosphere. When our planet was still just a young pup, volcanic gases are what created our protective bubble that allows you and me to breathe right now. They also played a big part in shaping the land and oceans. 4 billion years ago, Earth was still forming. It didn't look anything like the pale blue dot we know today. It was red hot, and the water was trapped under the crust. It wasn't until the surface started to cool down and solidify that the water was finally able to escape. Volcanoes acted sort of like a tear in the fabric of our planet. Water vapor would condense in the atmosphere and then fall back down as rain. It rained for so long that the third planet from the sun started turning into the blue ball we're more familiar with. In fact, there's even a theory that all the water on Earth came from volcanoes. And without water, of course, life wouldn't have been able to form. Land formation went through a similar process. You see, our planet was a pretty rough place to be when it was forming. It was a molten surface with fields of lava and constant volcanic eruptions and space rocks always crashing into it, because there was no atmosphere to protect it. When it started cooling down, a good solid surface formed, but the hot material underneath was still boiling and bubbling, and it continued making its way up. The crust would move and form thick layers with the material that was rising up. Over time, these layers became more permanent. Volcanic eruptions were still happening, but the first landmass had finally formed. Okay, we'll take the best part of volcanoes, an atmosphere. So what if they stopped erupting long after we got our protective breathable shield? Still not good. For starters, volcanoes created the most fertile soil. Around Naples, you have the famous Mount Vesuvius. The soil quality there is incredibly rich, and that's thanks to 2 huge volcanic eruptions, one that happened 35,000 years ago and another 12,000 years ago. Sure, these volcanoes caused a lot of short-term damage, but in the long run, these soils were fertilized by them. Now the region grows all kinds of citrus fruits, olives, grapes, cherries, and of course, their staple, tomatoes. There'd be none of that without rich volcanic soil, and Naples is by far not the only example like this. Bacteria, the first living organisms, lived in hot water. Scientists have discovered fossilized microorganisms older than 4 billion years. They thrived in hydrothermal vents. Those are fissures on the sea floor, and they're usually near volcanically active places. This means that without volcanoes, we wouldn't have land, water, or even the first life forms that, as the theory goes, would eventually evolve into all the creatures we have today. Could life have still developed on Earth without these explosive mountains? Doubtful. Okay, fair enough. We want our atmosphere and life. So let's say volcanoes stopped erupting today, after we already have all these benefits. Well, we're sort of already there, based on this story. At the start, there was only one continent, Pangaea. It was a supercontinent surrounded by one massive continuous superocean. Volcanic activity by this time had finally calmed down, and this meant all that energy would gather below the Earth's crust. Here's a little diagram. First, we have the Earth's inner core. Then there's the outer core. Next up, we have our convection currents. Magma is next in line. After that, the oceanic crust. And at the very top, we have our ocean and our continental crust. The reason Pangaea eventually broke up into the separate continents we have today is because of plate tectonics. It's not like the crust is all one solid piece. It's broken up into big chunks, or plates, that are always moving. And it's all still moving today. Yes, the land you're standing on right now is sort of surfing on that layer of convection currents. It's a slow process, so it's not like you can feel it. Pangaea didn't break apart all at once. It took tens of millions of years. When the plates move, they cause earthquakes and volcanic activity. They create mountains too. It's good for our planet as well, because the Earth gets to sort of renew its old crust. If there was no volcanic activity now, the pressure underneath the Earth's crust would keep building up. It'd get to a boiling point the continents couldn't handle anymore, and eventually, they'd start splitting into more numerous and smaller masses. Volcanoes are still useful to us till this day. For one, they cool our atmosphere. Their eruptions release sulfur gas. It combines with water in our atmosphere and cools it at its lowest level, which is where we live and breathe. There's also an excellent use for their heat. Geothermal power plants harness the energy coming from deep inside the Earth and turn its heat into steam. We then use that steam and turn it into electricity. This is the case for our friends in New Zealand and Iceland, since they live in places with high underground temperatures. Volcanic material can also be made into blocks for building stuff. It can be grounded down to make cement too. If we want, we can even search volcanoes for precious minerals like gold, copper, and sulfur. And who can forget about hot springs? Tourism to places like Yellowstone and Iceland wouldn't be the same without them. And who doesn't love a nice steamy dip in the ones safe for swimming? Oh yeah. In the end, volcanoes aren't so bad after all. Our beautiful Earth wouldn't be what it is without them.
Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank one bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for two main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this: a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia Subduction Zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of 2 completely different zones: the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the 2 regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the High Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So, while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another. sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just